Okay. Oh, I don't appear to be on the screen. Well, that's an interesting failure. Let's see what's happening there. Okay. I'm invisible. I'm a ghost. Oh my god! Already someone found a new background. Okay. It could be due to this. There we go. It's the wrong camera though. That one. There we go. Am I in the car yet? Maybe. Happy Saturday, everybody. Praise be the spiral. Sorry, it's nothing. I'm just drinking the ice, melted ice water out of the bottom of here, so I can actually put some vodka in there. So we're going to drink vodka again tonight. I've got about a quarter of a bottle of this one left. I've got another bottle in the freezer if I run out, which I'm sure I will. And I've got some random drinks tonight. So I've got some kawaii kiwi and fruit punch. So I'm going to try the kiwi first to mix with the drinks. You got vodka lemon, nice. So this is vodka kiwi, so raspberry vodka and kiwi drink. So hoping it's quite nice. Interesting flavor for sure. Are you considering making a true Kart game with famous characters from C64? Yes, indeed. That's exactly. Oh, that was a funny noise. That's exactly what I'm going to try and do. So thank you very much for the let's go through all of them first. So thank you for the host, Prow7, Andy Magic Knight, and Prince Face. Thank you very much for that. And thank you for the resub. 12 months, wow, from Grey Defender. Cheers. It's not Yuppie cars in it. Yeah. Oh, yeah. So I'll answer that question in a minute about the dock car. So there is a new command, BG theme, as Steps has typed in there. You can do that on any series that has been discovered. 75% or more of the images. So you can't do it on new series. You have to get 75% of them before. But yes, to answer the question, what I'm aiming to do is create a Mario Kart style game in the style of the SNES version of Mario Kart, with a lot of the similar kind of power ups and things feeling roughly like Mario Kart, but with different graphics, obviously, and probably characters from the C64 and Amiga. There'd probably be C64 characters, I think, mostly. But yeah, it's gonna be pretty good, I think. BG reveal all 8. Come on. Oh, don't you? Yes. So yeah, I think it'll be quite interesting, and I think what I'm going to do is once we've got the game working and kind of once we get to the point where we need graphics for it, the track graphics I'm not too fussed about, because tracks are generally just a flat texture, pretty easy to do. But the carts themselves, I'm going to draw an empty cart, or get someone to help me draw an empty cart from all the different angles that we need it from. The carts will be scaled dynamically, so you only have to draw one scale. You don't have to draw all the different scales. They will be scaled dynamically using DMA, either before generated at launch time or done on the fly. I'm not sure yet. Depends on raster time and what's required. But once I've got empty carts, what I'll do is I'll share those files with everybody, and it's if you want to make a driver for that cart, then by all means go ahead and make a driver for that cart, and maybe we'll pick the kind of top 8 racers from that list. So that would be kind of cool. You can get your racer in the game. But yeah, that's exactly what I'm intending on doing anyway. It'd be good, yeah, if we could have a mixture as well of male and female. I know there's not many female characters on the C64. It was that kind of era, wasn't it, where everything was still male protagonists. But there's a few. The Guyana sisters, as someone has mentioned before. I'll try to think of more. There's definitely more. So it'd be good if we could get a mix in there. That would be good. Um, yeah, we'll look at that when we get to it. It'll be a little while before we do that. Right. So let me add some points to you all, and then I'll explain what we're going to do tonight. Uh, okay, so there we go. Also, I'm not sure why Andy gave me a new picture of his dog for his image, but it's obviously kept the old one cached, and I'm not sure how to empty the cache on this OBS browser. So I'll have to look into that. I'm not sure why that's happened, but it's surprising because the Mr. Mem, some of the Mr. Mem ones were changed, and they worked absolutely fine. So I'm not sure what the difference is, but yeah. Anyway, yeah. So other news as well before I start the races and explain what we're going to do tonight. The background has got a few new features on it. The BG theme you've already seen. If a series comes up and you've discovered 75% or more of that series, you can do BG theme and put the series number in, and it will give you the author of that series and the theme for that series, which is the important bit there. Thank you, Anton, for the bits. Thank you very much. Welcome to the stream. Oh, it's a bit strange that with kiwi in it. It's all right, but it's not as good as lime. I had no lime, and I ordered some in the shopping, but they had none, so I didn't get any lime soda, unfortunately. So I'm kind of stuck with finding random mixes. I've got quite a lot of different things to try. So, but kiwi and vodka is a strange combination. A kiwi, raspberry, and vodka is a strange combination, I should say. I don't know why I'm getting that weird sound glitch when the alerts go up. That's really strange. I don't know if you guys can hear that when it happens. But thank you very much for the gift sub to Steps, Andy. Thank you for the bits, SP. Dot Cosmos arrived. Yeah, so I've not got it on my desk. I will be giving a copy of Dot Cosmos away at the end of this month as well. So even if you've already got a copy, you can enter and potentially win it for somebody else who who's got a Game Boy Color and would enjoy the game. So, oh my god, here we go. Anton, thank you very much for the 5 gift subs to Crazy Battener, Stephen Layson, Russell Mills, Thalamus, and Notimic. Not iMike, not Imic, not Timic, not Timic. I'm going to call you not Timic. Thank you very much for that as well. Cheers. So, and the other thing that's with the BGs is when you do get oh my god, you're all going mental with the bits again. Stop it, guys. We're already definitely doing a double giveaway next month. It's possibly even a triple giveaway. We're going to do we're definitely going to do two Nexus boards. I've got them ordered as well. They should be coming relative. Oh no, I've got one of them ordered because I've got this month's winners board and next month's winners board ordered. But I will be getting another one next month. And also I'll be doing a Pi 400 giveaway as well next month. So thank you very much for the bits as well, Deft. Thank you very much for the bits, Steps. And thank you very much for the bits again, Anton. Behave. Oh wow. Yeah, you're all mental. I will drink this entire vodka now because you've been really good. So, so what was I saying? Oh yeah, if you do guess something that's in a series, up here where where the series number appears, it will also have the author after it as well. So now if you create a series, you'll get your little name up there next to the series info. A couple of reasons for that. One, oh god, I'm going to try the fruit punch with the next one. One to basically give you a little bit of incentive to make a series background, so you can have your name up there. I don't know how much of an incentive that is. It may not be, but it's a another reason for potentially wanting to do that. So this one is fruit punch. Anton, you're mental. I owe you like a million beers now, or a million wines, or whatever your tipple is. It'll be wine. It's got to be wine, hasn't it? Thank you very much for the gift subs. Let me get a drink poured so I can actually toast. 5 gift subs from Anton. Thank you very much to Team R&B, to Zypho, to Buzzley567, to Deb000, and to Retro Rusty as well. Cheers. Ooh. I just need to try that on its own. Yeah, I thought so. It's got grapefruit in it. Oh. Oh yeah, sweet grapefruit juice. Thought so. Grapefruit juice is very weird. It's awful stream. Yeah, and that's the thing as well. Thank you very much for all of this, because it all does go straight back into the giveaways and to the stuff we do on the channel every week, and we'll continue to do to the end of the year. And then who knows what we're going to do next year? Sometime next year we will do something else, I'm sure. But I really do enjoy doing the giveaways. So thank you very much for that. Cheers, Microman, as well, for the 234 bits as well. You can stash some boards for the upcoming months. Yeah. I mean, I'm not going to do a double giveaway every month. It's only really when the money piles up quite a lot in one month, then like that. It wasn't quite enough this month, but with this month as well, it's definitely way over the 2 boards. So I definitely want to do 2 next month. But some some months we will just do single ones. Sometimes we'll give away 2. Okay, yeah, I will be drunk before I've even coded one line. All right, let me start the races and I'll tell you what we're going to do. Let me find the button. There it is. Oh my god, Fitrend, thank you for the bits. Kenneth Mirror, thank you for the bits as well. Very much appreciated. Okay, level 6. Let's code. Yes. Oh god. Okay, so what we're going to do tonight? Let me show you where we're at on the thing. Oh, is it on no sig? Oh, because I'm on the wrong thing. Or do I have to reset it? I think I might have to reset it. Oh no, there we go. Still says no signal though. That's weird. No signal, except there is a signal. That's kind of cool. Resident Evil came up. I think that's really funny. Thank you, Anton, again for the bits. You're a madman, absolute madman. All right, let me turn that off. Oh god, where's the? There we go. Turn it back on. No signal's very annoying, isn't it? Deactivate, activate. There we go. All right. So when we last did this was Tuesday. We'd got to this point. Let me run this version, and I'll explain what it is, what it was doing, and then I will explain kind of what I've done since then. So what this is doing, this is actually copying what a special buffer format that we've come up with that lives just above all the character that make up the characters that make up the bitmap, and basically the buffer just contains all the information that needs to be scaled and drawn to the screen. So it contains the unscaled data. So if you imagine, actually, let me boot up. No, not that. Let me boot up this as well because it helps to explain. It's good to have this open to explain. So yes, I am running a Python script. Well, I'm running something on Python, not a Python script really. It's just a Python command that's really useful for running a server kind of. Oh, is it displaying nothing? That's weird. Okay, there's a bug somewhere. Let me just check. I probably typed something random in there. Yeah, thought as much. Oh, what's that about? All right. Don't know what that's about. Weird. Eight is not defined. What? 6.2. Right, there we go. So what this is actually doing is taking the data that's scanned from each one of these lines. Probably kind of hard to see that, but we talked about it last time that the algorithm works by taking increasingly shrinking lines. So if you start from the very like the very distant point of the horizon, basically, the line is really long, and then as you get closer to the camera, the line gets smaller and smaller and smaller. Forms this cone that you can see in black here, with the lines getting closer and closer together. As you approach the camera, and that's the kind of perspective view that gives us the 3D. And what's happening is the algorithm, the algorithm that's drawing this colored thing here is basically all of these lines, one after another, are just stored in memory unscaled, so they're all the correct length. So the top line is really long, and the line closest to the camera is really short. And what the code that we did on Tuesday does is it takes those lines, draws them to the screen in rows. Each line moves down one vertical row on the screen, but stretches that line out so it fits the whole screen. So it basically makes all the lines the same length. So what it's actually doing is that the somewhere in the middle is about what the screen width is. So the lines that are in the far distance are shrunk down to fit the screen, and the lines that are closer to the camera are expanded to fit the screen, basically turning it from a cone into a rectangle where everything is exactly the same length. And that's what this algorithm is doing. And that's why you get a kind of pseudo 3D effect on here, because what we wrote to that buffer was a load of colors in the order that they are on the C64, one after another. Um, and basically, the algorithm takes those colors and just expands them. Each one is expanded a little bit more than the last. So in the far distance, you can see all the colors kind of take up 1 pixel, but as you approach the camera, the colors are taking, the very bottom row on here, the colors are taking, about a third, well, over a third, actually. I would say, yeah, 40% or so of the screen is taken up by one single band of color. And so you can see the 3D effect. If you look at, say, the red band there, you can see that close to the camera it's a particular size, but as you move into the distance, it gets smaller and smaller. So you can imagine this being a red stripe, the same width leading off into the distance. When viewed with perspective, it looks like it's getting thinner and thinner and thinner, and it's really wide at the camera. So that was the algorithm that we did on Tuesday, and that proved that we could copy that data, and it would work kind of exactly how we wanted it to work. So what I did was, yesterday I spent a little bit of time, probably a little bit more than I kind of wanted to. Thalamus and his Steve Rowe. That sounds a bit quiet. That music actually. Is it just me or is that quiet? Let me change headphones. Yeah, there we go. So the SNES version uses a D-pad, but also both shoulder buttons and two fire buttons. I think something to think about. Yeah, I mean, you can't hear it. I thought it was a bit quiet. Let me turn it up slightly. There we go. So what we're going to do, let me know if it's too loud now, because I realize it's a fine balance between my voice and the music. So also the music should get a bit quiet when I talk anyway. I've got it linked to the mic. So Yeah, so I have been thinking about that a little bit. Obviously, the fire button, I want to maintain that as being the shoot button. There is going to be some kind of power ups. I'm not sure what it's going to be. We've got a couple of games to kind of draw ideas from. You've got Wipeout, you've got Roll Cage is another one. You've got Mario Kart, obviously, and all the other kart variants. So there's a lot of different kart games we can look at, and kart games and weapon-based racing games that we can take a look at for ideas. Um, but yeah, I want to keep that on the fire button. But what I was thinking is it could be something like because you're going to be using forward to accelerate, right? It's going to be push forward to accelerate, fire button to. Yeah, I'm not sure how it's going to work. We need to have a think about that because you kind of want the shoulder buttons to jump as you go around the corners. Um, yeah. Can we have the Sublime 2 clicks bigger? Oh, this is Visual Studio Code. Let me shrink that down. That should be, yeah, there you go. So yeah, anyway, what I did on Friday yesterday was I started looking at the other half of the algorithm. So this is the algorithm that copies from the buffer to the screen, but then we need the algorithm which actually fills the buffer in. So we were originally just doing this um, with some dummy data that we filled in using this fill buffer dummy thing here. So I took that out and I changed the routine to instead be fetching from the screen, fetching from the texture buffer. So not even really a buffer, just the texture loaded into memory. So currently the texture is loaded in at the 128 kilobyte mark on address 20000, and that runs all the way up to 5FFF, which is the end of the memory of the fast chip RAM memory. So anything above that, unfortunately, can't really be used. So we're filling quite a lot of the memory. We're filling 256 kilobytes of memory. But I'll talk a little bit about that once I've demonstrated the where we're at now with it, and why that doesn't really matter too much moving forward. Um, so yeah, I put the texture there. That's loaded in now using a floppy routine. So again, these floppy commands are available in my library, and they will be available in this repo, which I'm going to use as my kind of demonstration library. And this is the one that you should probably pull all the latest includes from. So not just that, but the floppy IO, the macros as well will be in here, as well as the tools that I use uh, to convert the assets as well. So yeah, in fact, that's trying to load up into Attigram, so I should probably change that. There we go. I think the Klingons are messing with spacing. This is 10 seconds tonight. Oh, this is a good tune. Yeah, it's so frustrating. I think I honestly believe if you make partner, you get a better connection. I think they do prioritize Twitch partners over affiliates and non-affiliates for bandwidth and stuff, which kind of makes sense because partners is where their money's at, right? So anyway, yeah, so this is now loaded up into there, and then this routine does all the tedious maths that's involved. Now, this took me a while to do. The reason it took me a while to do is for a couple of reasons. One, I made a few mistakes as I was going through it. Fairly easy mistakes to make when you're converting a lot of maths. And the second thing is something I didn't realize until quite a bit later on, which I'll talk about when I get to it as well. So let's just quickly go through the code. Well, let me leave it running on the screen so you can see what it does, and then I will. I mean, I'm sure most of you seen this anyway. I was very excited when it was working, so it did get posted in a few places. But there you go. So what I did was I took the code, the JavaScript code, and I took a look at every part of this and thought, okay, what do I need to do to convert this into fast assembly? So I looked at things like all these variables that we set up here. So there's a few things that happen in the render loop. Let me just move this over so you can see it, and let me make it a little bit bigger. I realize it's JavaScript; it might not be everybody's cup of tea, but it is what we're working with on the prototype. So there's a few variables that are set up here. Um, so my first thought was, well, I can probably make most of these tables. Um, so I took those values and I pre-calculated them. So you'll notice in here that they use these variables here use these variables here. So all I really need to do is get these variables kind of set up, and then these ones are kind of easy to create. And these variables use the field of view to create what is essentially the left hand side of the cone, the left hand line of the cone, and the right hand line of the cone as well. Um, uh, let's go. The pickups, I presume, will not be part of the original text once you have it working as a game. No, they will. They will. Because what you do is you put the pickups on the track like that, and then you just draw over them. You just paint over them when you want to remove them. So in the case of coins, you would draw over them with the grey color of the track, and that will remove them. It's pretty easy to do. Once you hit a coin, you have a kind of rectangular area that you can draw over. DMA would remove that in no time. And with the pickup question marks, you would you just change the color on those. So you would look for all the colors within a certain area and just change them so they look like they're inactive. So yeah, so I took these near and far coordinates. So near one and far one. So this is I don't know what the M is for here, but I obviously felt that was a letter I needed to put in there for some reason. But near one and far one are basically the I'll show you on here. I basically the point here. So this is near one at the bottom of the cone on the left hand side. This point here, and far one is the point on the furthest line on the left hand side, and then near two is the same but on the right hand side, and far two is the same on the right hand side. So the first thing I thought was, well, no matter where you rotate, these are always going to be the same distance away from your center point here. So all I really need is for every angle what the offset is from my point here, which is calculated from cosines and sines. So I went ahead and made tables for those, which you will see here. So I have near one, fractional, integer, and most significant byte. So it goes up, it's in three pieces because we need the fractional value, we need the integer value, and then we need the MSB integer value as well. I did not see him working on it. No, I did this yesterday. I wanted to, and I'm glad I did as well because it took me a while to get this right, and it would have been a very boring stream. So it would have, it would have taken some time, and I don't think we would have got it working in a 5-hour stream anyway. It took me probably about 5 hours of non-stream time, which is kind of double what it would take on a stream, so half of what it would take on a stream. So but I'm going to go through it all now anyway. So yeah, so I create tables for near one, near two, in both X and Y, and then I do the same for far. Wait, near one, near two. Wait, where's my far values? Wait, what? It should have far values. Where are they? Near one, near two. Oh, maybe I don't. Maybe I took them out because I don't need them anymore. Anyway, the whole point is that I use these these properties that I can pre-calculate to save me time having to do this mathematically on the fly. So one of them is the offset. So if you imagine the player here, where the two lines of the edges of the cone would meet, then all I'm storing is the offset and to these points. And actually, what I will be doing soon is changing it. So instead of storing the left and right, I just store the point in the middle, and then the left and right would just be, okay, here's the point at 0 degrees, and then this is at minus half of the field of view degrees, and this is at plus half of the field of view degrees, so I can half the number of tables I need. So that's one of the optimizations I will be doing soon. The other thing I record is the delta of the x and the y. So what this is the difference between here, between the point, the near point, and the far point. So I know that if I'm at this angle here, then I need to travel a small amount along the x and quite a lot along the y to get to this point. And I have those exact values, and they're needed so that we can work out where each of the horizontal lines are. Again, they're just pre-calculated, very easy to do as well. Um, nothing complicated in here at all. And then finally, slope. And what the slope is the actual difference. So if you look at this slope here, um, it's how many for every pixel along the major axis, so the axis that changes the most, how much do you change on the minor axis? And that's what we're going to need for rotation. I haven't actually implemented much of this yet. There is a little bit implemented, but not all of it. So that's what the tables were doing. Get some more alcohol in me. Well, I'm not sure about that, Job. It's the grapefruit. Not sure about the grapefruit at all. Oh, there you go. Another series. Telling you can't buy. I got a PS5. Woo! Should be coming this week, hopefully. I've been approved. I got it from shop2.net. If anybody's looking for a good kind of supplier, what they do is they vet every single purchase. So when you order it, you actually get credit on the store, and you are what's known as on back order. Now, normally that would mean that you don't actually have it yet. Oh, there's the Sid music is always getting louder when you speak and unhearable once you stop. Oh, that's the wrong way round. Let's knock it down a little bit. Just a tad. There we go. Yeah, so what they do is they put it on back order, which means normally it would mean they don't have it in stock, but they do have it in stock. But what they're doing is they then verify that you haven't used the credit card, the address, or the IP number or something like that. They check a load of details to make sure that you haven't already bought one, just to make sure that they can, try and get them into as many hands of actual users as possible, and not as many scalpers. And I also, if they for any whatever reason you fail that verification, they charge you £20 for it for failing it. So they automatically take money off you for doing that. So it seemed to work fine for me, and I managed to get one. I mean, I did have to enter a queue, and I was in a queue position like 5,000 or something after like 7 minutes of them being live. So you still have to have a bit of luck with the timing, but I think that was the easiest process compared to others, I think. Anyway, right, let's go through some more. So here I'm just building the list which is used for this. So this is just building a list of near and far. Oh, that's what this is. Near and yeah, this is near and far together, I think. So actually it's not, is it, looking at that? But anyway, it doesn't matter. Okay, so let's go through what the math is actually doing. So the first thing it's doing is it's grabbing the deltas. So it's grabbing given the angle that you're at. So it grabs the angle from this here, which is just basically the parameters for the player. So oh, still with me, but I'm very picky. Yeah, trust me, I have had no end of trouble getting this just right for skunk monkey. I've had no end of trouble trying to get it just right. It's impossible to satisfy everybody. So yeah, the audio ducking was kind of necessary because I either had to have the music completely off, or too loud for my voice to be heard over it. So okay, let's get some more alcohol. Yeah, I need to get through that tropical. It's not great. That's one for later when I've had enough to not care what it tastes like. Okay. So yeah, this is just taking the current angle and it's working out the deltas. So it's working out the x and y difference between for the left and the right side, and storing them in variables so I don't have to do index lookups later on. Um, this is going to save us a few because we will be referencing these variables a lot within the loop. So if we had to add indexed lookups every time, it's an extra cycle every time we want to look one up. So having these kind of pre-calculated ahead of time, pre-fetched ahead of time, and storing them in these variables saves us a bit of time. The comments above them show what the equivalent JavaScript was that it's replacing. This just helped me kind of see where I was going with this. A few things have been simplified, so some of it probably isn't as relevant anymore. So, for instance, this one here, which calculated which row of the screen the rendering would start on. Previously, that was calculated in the JavaScript, and what I realized is I could remove some of the things. So one of the things I removed was the calculation that needed to do that, and the plain multiplier, which I no longer need. I can generate the same effect just by starting the row later myself. So that's what I'm doing there, and that's why it's a nice simple one. Load a value and store it. So, um, how much rest time are you using? That's a good point. Let me show you. So there are two important things going on here. There's the initial texture texture to buffer, and then there's buffer to screen. So the first one you will see is the first line you will see is texture to buffer, which is the bigger of the two, because it has to read more pixels. And the second one is the buffer to screen, but you can see it's not using much at all, and this is not optimal either at the moment. So um, so yeah, you can see it's pretty decent. I mean, that's it's less than half of a screen, just. And obviously, the less we draw, the more that will improve. But the important thing to note here as well is if I change, let me just quickly do this. So if I just change the DMA that does the fetch, and instead of fetching from chip RAM, I fetch from Attic RAM, which is slower RAM but has 8 MB instead of 384 kilobytes. You will see that it's not a huge slowdown. It does use more, but it's not much more. So you can see it's using more than half the screen now, but it's not using an entire frame. It's probably doubled the amount of time it takes to do the fetch. So I think with a bit of optimization, we can bring that right down, and that will allow us to use really big textures. So we'll be able to use like 2048 by 2048 textures. Although I think that's probably too big. It'll probably be 1000 by 1024 by 1024, which will give us quite detailed textures. So, but yeah, you can see there that's running pretty smoothly still. Although it's obviously it's fetching junk because there's nothing up in Attic RAM yet. But yeah, there we go. So what we're going to try and do tonight is we're going to try and put the rotation in, which I have got partly working for the same like we were doing the line where it's done in quadrants. Um, uh, so I've got the first quadrant working. Well, the first half of the first quadrant working. So we just need to go through those and add those in. But I'll talk about them when we get to them. So yeah, I take the row start and I store that, and then this is where the loop begins. So this is where the meat of the algorithm comes in. So I'm using the hardware multiplier and divider, and this allows me to do division, multiplication, and this is where I had my first kind of stumbling block yesterday. Cash in the attic. Oh wow, that's joke of the month. That I like that. So for those who don't know British TV, there is a daytime TV show called Cash in the Attic, um, where members of the public basically look for antiques, uh, and sell them. So auction, something like that. Yeah, it's something like that. Yeah, yeah. But so that's kind of a good joke. That I like that. Yeah, it's quite famous as well because there's a particular guy who hosts it or used to host it. I don't know if he still does. He's very well known, a very kind of flamboyant personality, and a creosote coloured skin. He's pretty sure he's dipped himself in creosote. Can't remember his name now. Is it David Dickinson? I think it is. Um, and he's kind of made that kind of show well known because of him really, and because of everybody who's got no job, sits at home, just watches it. So yeah, anyway, so this was my first stumbling block, was the hardware divisor. And I actually had two things that I was doing wrong on here. The first thing that I was doing was a really stupid mistake of mine. I was treating the hardware divisor as big endian instead of little endian, and I was getting all sorts of weird results back from it, and I couldn't figure out why. And it turned out I was just being really dumb, and it should have been using a little endian. So that was my first kind of 20 minutes or so of struggling with it. But then I got really, really stuck on it in benign titanium for my what am I missing? I'm not sure. Catch the rare stuff. Okay. How much? Oh, the gambling. I see. So yeah. So the second problem that I had, and this was the one that really was a major stumbling block for me, and I couldn't quite figure out what the hell was going on because I couldn't work out exactly where it was. I'd gone ahead and done all the maths that I needed, but when I ran it, I was getting all sorts of weird results. So what I was doing is I was doing all of this maths, and then I was putting a breakpoint down here somewhere and checking the results. Yeah, I think it was around about here. No, after that, it was around about here. And the results I was getting just didn't make any sense. And what I realized, it took me a while. It must have been about 2 hours before I realized what was going on. Was that the hardware divisor doesn't work with negative numbers, so it's an unsigned divisor. So that produced a little problem in that I had some dx and dy values, so not these ones here, but these ones here that are using the dx values, which are the distance, the delta x and the delta y. Some of them go backwards. So if you imagine you're facing straight up. Let me show you again on here. If you're facing straight up like that, then your delta x is going to be negative, and your delta x1 is going to be negative, and your delta x 2 is going to be positive. So this is going to be negative, this is going to be positive. But the divisor doesn't work with negative numbers, and it took me a while to realize that. The reason I was getting values that were incorrect is because it was just dividing a really big number, rather than a small negative number. So when I realized that, I had to make some changes to my code. So the first thing I did was change the tables. So what you'll see down here is the delta values are actually made up of three components. I've got the fractional component, the integer component, and you'll notice that they're all using ABS. So this is to make sure that the deltas are always going to be positive, and then there's the sign value here. So this dx1s is the sign of these calculations. So this just records whether something is positive or negative, and just writes 0 or ff into the array. Now there might be a way for me to shorten this, and I'm sure I will find it at some point. I'm thinking probably the upper bit on this one. But the idea is when you do that calculation, let me find it where it's being used. God, where is it? Yeah, here we go. So it does a calculation, and then it checks if it's positive or if the result should be positive or negative. So if you get -1 and divide it by 1, your answer is -1. But obviously that won't work in the multiplier, in the divisor hardware math unit. So what you have to do instead is you have to do 1 divided by 1, and remember that you're doing minus divided by positive, so your answer should be negative. So you then just basically check that sign value and then go and negate the value. So that's what this is doing here. So oops, depending on the result, it either just stores the result directly, or it negates the result and stores it. So what this entire math block is doing, first of all, it's working out the view, um, the depth factor. So this is the perspective correction. So this is holy piss, just make a platform game. No, no, no. Uh, uh, yeah. So the depth factor is basically you can think of it as kind of like the percentage you are away from the camera. So that's what works out whether this line is 10 units away or 1,000 units away. But make sure that the lines get gradually further apart as you move off into the distance. This is what creates our proper perspective correction, and allows the view as you see it there. So that's what this bit is doing here. That is loading the current row of the screen that you're on, because as you move down the screen, you get closer to the camera, and it divides that by the row height. So that gives us a fraction from, say, 1 over 128 at the top of the screen to 1 at the bottom of the screen. And then what we can do is we can invert that, and that gives us a small number at the bottom of the screen, a large number at the top, and they get gradually further and further apart as you move up the screen. Um, Let me see. So yeah, so that's what that's doing. The hardware math unit needs to waste a couple of cycles. I found loading the value 3 times um, was enough to waste cycles, so that on the fourth time you read it, you actually get the result that you want. Um, Interestingly, as well, you have a 32-bit number for your inputs, and you have a 64-bit number for your output for a division. Well, actually, for division and multiplication. So what you get is 32-bit divided by 32-bit gives you a 32-bit result with a 32-bit decimal value as well. So you can get your fractional values there as well. So that's what this is doing. This is just storing this in what we call depth factor. It's called df here. It stores it automatically into the multiplier, but also stores it in this location here in case we need it. One optimization is probably to remove this. I don't think we need it. I think the only reason I kept that in there was so that I could read that value for debugging purposes. And then we go on to working out where the points are. So what we need to know, once we know how far away the particular line is where our x and y positions are for those points along the line. So given a line anywhere here, so let's pick the furthest away line here. We need to know the x and y position of the leftmost coordinate here, and we need to know the x and y of the rightmost coordinate here. And that's what these are doing. They seem really long, but that's because what they're doing is they're working out where the x and y is based on the values that we have in the tables, which we've already stored in dx1 here. Is it not scrolling? Have I got? Yeah, I've got that open. And it stores the initial values into px1, which is our position x1, position x2, position y1, position y2, or point x1. Yeah, and negates them if they need to because of the sign values. And then it also adds the depth factor on divides that by the depth factor. So it takes our delta value, divides it by the depth factor, and that gives us the correct distance along the line. And then it just adds the player position on as well, because what we've got is an offset. So we just need to add the offset to our player position, and we get where we are on that line. And that's what this is doing. There's a lot in here, and this math took me a while to figure out. And there's one for each of the four x and y and py, px1, px2, py1, py2. Then once you've got them, you can use Pythagoras to work out the length of the buffer. This was pretty easy to do because you don't actually have to. Normally, if you want the length of the line, we'd use Pythagoras, and you would get the you would get the hypotenuse, which is the actual length along the line. But what we want is the length of the major axis, and that's easy. We just take px2 minus px1, py2 minus py1, whichever one is biggest, that's our length. Nice and easy. When you showed the raster time use, is it CPU cycles consumed or reflecting DMA copy time, which actually does not use it? It's raster time consumed. So even though you are not using the CPU, you're still using raster time while you're doing DMA stuff. So this is the grey bar that you see there is everything that you see in this fetch loop. So it's all the DMA, all the pre-calculation, everything. So um, the best thing about this Mega65, the bra command, oh, is it? Yeah, yeah, bra set as well. There you go. Oh, I should have done that, shouldn't I? I'll remember that for next time I do those. But yeah. um, so yeah, so with that we've got the start of the line, the end of the line, and the length of the major axis of the line. That's almost everything we need to draw our line. So the DMA line drawing algorithm, or which actually doubles as a fetch algorithm as well, needs the start position of the line in memory. It needs the length of the line and the slope of the line. You didn't change that label properly, did I not? I did. Oh, do you mean like that? I don't know what you mean. I'm not changing it. I'm going to leave it as it is. We're going to go through the code quickly, and then say quickly. It's almost been an hour, but once we've done this, we'll actually get onto the code. Um, oh, you thought I made a typo? Okay, no. Um, so the length is important because what the length is the header for our buffer. So you remember the buffer that we made as a 2 byte length header followed by all the data for that particular line. So that's what we at this point now we can store that length, and we store that in the buffer for this particular line. Then we can look up the slope, and we can store those as well. So the DMA job is called the fetch job. And the slopes are pre-calculated. So if you're facing in a direction, all the lines have got the same slope. It doesn't matter where you are, which line you're drawing. They've all got exactly the same slope. They've all got the same gradient. So I can store those in a table, which is what I'm doing down here. I'm calculating what the angle, the slope of those lines are, and I'm storing it in the slope variables in the fetch job. So then the only thing that's really left to do is to take the you just got booby blind. uh, so the only thing we need to do now is we need to take our X and our Y position. So all we've got at the moment is a coordinate in this texture. So we know where we are in this section. In this case, we're at this dot here. So we know that would be like X, 256, Y 456. I think that's exactly what it is actually. But to convert that into something that the DMA can understand, because the DMA knows nothing about the texture. All it knows is that it needs to copy things in this particular step, basically. So every time it moves one this way, it needs to move a fractional amount down. And every time it reaches the edge of a character border, in other words, every kind of eighth column or every eighth row, it knows what step it needs to do to get onto the next character in either direction. So we need to convert that into an actual memory address as well, and that's what this little bit of math does here. Just takes it takes the X position, the Y position, col step, which is this thing here, which basically just works out if you want to move from the 7th column to the 8th column in the texture, how many bytes do you need to add to how many numbers do you need to add to the address? So yeah. uh, ah, yeah, I put some kind of bounds checking in, because what I didn't want you to do is so you can work out how many series there are um, by checking big numbers and then reducing it until it says that it does exist, but you don't have enough. But you can't figure out what the series is. You have to get 75% to get the series. So um, no, it doesn't catch drop table, but then I'm not using SQL, so it shouldn't be a problem at all. I'm not using any database, weirdly. Thank you very much, 6502 Kebab, for the resub. I want to get through this and to move on to it. I'm going to get a Fanta from over there and have a vodka and orange. I think the kiwi wasn't bad actually. I think I will drink a kiwi rather than a Fanta. So yeah, this just takes the X, the Y, the step, and then it uses that along with the hardware multiplier because it does need to do quite a big multiplication here. It needs to take our X position divided by 8, our floored X position divided by 8, which is easy to do without the multiplier. This is what this is doing here. But it needs to multiply it by quite a big number. And the easiest way to do that is with the hardware multiplier. Now, the hardware multiplier resolves in 1 second, so well, 1 second in one cycle. So you don't need to do any extra fetches here. You can just fill the details in and then immediately read the results as well. And that's what this is doing here. It's reading those results and adding our source address on and storing it into the DMA job here. And then finally, it just advances to the next row and it runs the DMA job and then advances to the next row and it keeps on doing that till it gets to the bottom of the screen. And the result is what you see there, which is a pretty decent, facsimile of Mode 7. I mean, obviously it's not Mode 7. You could argue it is doing some hardware acceleration because we're using DMA to do the copies, but it's not really Mode 7 because we're still having to do the calculations. It's just we're simplifying them a lot. So, will you use sprites for the cards? I'm going to use raster rewrite buffer sprites. So, what the raster rewrite buffers, why I want to use the raster rewrite buffer sprites is it allows us to, first of all, have as many as we want on a line. Which means we're not going to run into weird multiplexing issues. We can have as many as the pixel clock will allow, but it also allows us to have kind of nice sizes as well. So if we say reserved 8 by 8 characters, that's 64 by 64, or maybe 6 by 12 or something like that. But we can we can reserve a good amount of characters for each car. But then also what it allows us to do is lay the data out in those exactly like we do with the screen. So they become little mini bitmaps as well. And then we can use the same kind of DMA routines to do DMA scaled sprites as well. So we can have a big sprite stored in memory. But when we copy it, we can say, oh, actually, we want this copied at 1/3 of the size, and it will copy it down to 1/3 of the size. The other thing as well is it makes it very easy for us to do layering as well. With sprites, you can still do it. You just have to swap which sprite numbers are on, but we can just decide if we just draw from back to front, it will always be the stuff that we draw first will be in the background. The stuff we draw last will be in the foreground. So you want your sprites medium, not rare. Yeah, let's get through this drink and then I can go on to the next one. But yeah, 7 months, 6502, very good. It's mad. I've been streaming now for over 2 years now, which blows my mind when I think about it. When I think back to the first time I streamed, I think how nervous I was about it and how shy I was about it. I really did not feel confident at all in doing it. But thankfully, my love of coding kind of made me feel a bit easy. It wasn't like I was doing something I didn't understand how to do. I was sharing what I already knew with you guys, and the alcohol as well. I made sure I had a little bit of a drink before it. So I'm having kiwi this time. It's the last one though. So I made sure I had a little bit of a drink before the stream, and I drank a lot during the stream, and it really helped. And it's not stopped helping since. To be honest, it's become one of the themes of the channel, hasn't it? Really. Tunisia as a whole, yes. So I do apologise for the locations in this because the list I used just listed Tunisia as the location. Apparently, it was used. Several locations in Tunisia were used for whatever this may be for. I'm not going to tell you what it's for. I'm pretty sure you've figured it out anyway. But Really enjoy my streams. You're doing a good job, and community's nice too. Yeah, I love the I love doing these streams. It's really fun to kind of to speak to all everybody involved in the community. The community is awesome. Both the community we built up around the C64 and now the Mega 65 community as well. It almost seems like when the two worlds of kind of Shallan Discord and Mega 65 kind of came together, it almost seems like the perfect fit because the Mega 65 community's attitude towards things is exactly like our attitude towards things. So it's been really, really nice to kind of work closely with those guys as well. And I think we're a perfect fit. I think. Um, apart from that, no one likes way. That's me. Uh, I'm going to do a new overlay at some point. I've been toying with the idea of just kind of doing an hour a night on it before I go to sleep and just putting it on my laptop and just working through it. Because I want to make I want to separate the admin panel out from it. Because what I foolishly did is I put everything into the overlay and then thought, oh shit, I need an admin panel, and I but basically, I mean, I can show you. If I just unlock the overlay and I just shrink it down a little bit, or I just move it up, you can see there's my admin panel. It's just underneath the page. Um, so what I have to do is I have to interact with the page through OBS, and then that gives me a little a panel that I can use. But what I want to do is make a little kind of node server with a few services on it, so like an admin service and an overlay service. I mean, that's what I was doing all day, every day for my job, so it wouldn't be difficult for me to do. Um, I just need to make sure I keep all the functionality and not lose any of it. Um, but yeah, I think. Yeah. Anyway, the world breaks. Yeah. Yeah, behind the curtain, you get to see there. But the overlays done me proud, and it's kind of evolved a lot, um, which is why it's such a mess because I've just been adding stuff to it over time rather than like redoing it. It's been very messily patched into it. Uh, well, the quiz came from Chiz actually. So Chiz did a quiz on his a Commodore based quiz on his. But what I very quickly realized is everything was very Googleable. So I wanted to make a quiz that was still kind of Commodore based or retro based, but less Googleable. So I've managed that with the quiz, but now I've created a background series with these things that you're all just googling anyway. So I'm pretty sure every background that you've discovered on here you've got from a Googled list somewhere, right? Pretty sure nobody's pulled these out of their memory. Maybe one or two, but not all of them. No way. But that's fine. That's fine. Um, I've started getting some series from people that are going to be way less Googleable anyway, so that's good. Google, yeah. All right, so let's look at what we want to do next. So I did start putting the rotation code in, which I'll show you now. So if I just change this, so instead of moving forward, what I'm going to do is I'm just going to change the angle. So what I'm going to do is I'm going to increment the angle, but then I'm just going to load that value. And I'm just going to AND it with 1F, and I'll show you why I'm doing that in a minute. But first of all, let me just do this. You'll see that the rotation actually works. So what the rotation is doing, um, when you change your angle, what it does is it basically changes your index in these tables. So these tables are just all the different X and Y's for every rotational point as you go around. So there's 256 points as you go around, and it's the same in this as well. I'm not using degrees in this. I'm using values from 0 to 256 in the JavaScript one as well, because I wanted to emulate the same sort of thing. Oh, incidentally, the JavaScript one has much smoother graphics on it now. I don't know if you can tell. Well, probably not on this because it's on 5.12, but you can see the edges are nice and smooth now. So I fixed a rounding error. But yeah, the tables are just one for every angle as you go around. And then basically, because and this is why I need to reduce some of the tables. At the moment, I've got like the left and the right, but what I could do is just have the one in the middle and then work out what the angle is for the left and what the angle is for the right, and that would save me some memory because this is quite a lot of memory. I think this uses about 8 kilobytes in tables. Um, so yeah, just changing the angle is just going to move where you are in that table. Um, and one of the things it does is change your slope. Um, so as well as your x and y, in other words, where the start and finish are of the line, it changes the slope. And if you remember when we were doing the line drawing with the kind of clock hand, we need to know where the line starts, where it ends, and what the change is along the minor axis. Um, and that's what this is. This is doing this slope. Let me just move that over so you can see. That's what slope LSB and slope MSB is. Actually, slope LSB is kind of, well, no, it is right because these are both fractional values basically, but this is a 16-bit fractional value. Um, cool holiday locations. Yeah, you don't know for sure. Yeah, that's true. But I mean, let's be honest. You've got most. I don't think you've been denied any of them so far. Um, okay, so yeah, the slope changes, and the thing is, for the very first quadrant, so the first quadrant or the first half of the first quadrant, the slope is going to be in a positive direction, and the slope is going to be exactly the y over the x or whatever it would be, or x. It would be. Hang on, we're facing this way, so our first quadrant is from here to here, so it's from 0 degrees to 45 degrees. Um, and it's not really a quadrant, it's half a quadrant. So the first half of the first quadrant basically goes from 0 to 45 degrees. And that means at all those points, our major axis is the x and our minor axis is the y. So the slope is y over x, because this means for every one thing in the x, how much do we move in the y? Well, the answer is y over x. And that's what this value is stored in here. And you can see that here you've got y, ABS y, far over ABS X far, and you can see, so this is calculating the angle of the slope just for that first 45 degrees. And so that's what we're doing here. We're just using first 45 degrees from 0 to 31 on our scale. And if we run this now, you will see, I mean, it'll be quite quick. It'll look a bit janky, but you'll get the idea. Oh, if I've done another one, have I done that again? Oh, because it's angle, that's why. So you can see it's moving to the right and then it's resetting again. So it's moving 45 degrees to the right and then it's resetting again. But you can see it is rotating, it is doing what we want it to do. So what we need to do now is we need to make this work for all the different angles. And this is where it gets tricky, because once you cross certain boundaries, the angles and the major axes change. So we need to change various things. So one of the things we need to change is the slope. This is the easiest of the lot, because this is just going to alternate between y over x and x over y, depending on which is the major or minor angle, and that's not going to change in negativity or positivity or negatively. But what it does mean is that we can reduce this down probably to 64. So we'll try that later on, but it's a potential avenue for size optimization, because we only need 64 values to cover all the values in the list. So he thinks that PSX image is right. What was that? I didn't even see what it was. Never mind. It says demo one. Oh, okay. I don't know what that is. I don't think demo one is a game. Oh well. Yeah, I wish I had the time to check every single image's name, but unfortunately I don't. So yeah, what we're going to do is we're going to add another value in here. So what I'm going to do first of all is I'm going to make sure that this repeats um, 8 times. And then what we're going to do is once we get this working, we'll simplify the code around this, or simplify the table around this. But for now, I'm just going to make sure it repeats, so there is no kind of inconsistency with between angle and the index. It's always going to be a value from 0 to 256. We'll reduce it down to 64 later on. Actually, it's be 4, wouldn't it? Not 8. And for now, let's just copy it like that. So we're going to change this in a minute, but for now, I'm just going to show you what happens if we try and go over that 45-degree angle. So you'll see the first 45 degrees looks fine, but then the second 45 degrees does weird stuff. I don't know if you saw that weird stretch, but it goes wrong, right? And if we go more than that, so if we go like for a full 180 degrees instead of just 90, it goes even weirder. And there you go. See, and that the reason that's happening now is because it's writing into very weird, strange places that it shouldn't be writing into. The buffer's being drawn too big in some cases, or too small in some cases. The values are wrong in it, and the DMA is getting stuck. Sometimes you can see the grey bars spreading out. It's because sometimes the DMA is taking way too long, probably because the lines are too long, because the values are wrong. So let's work our way around this circle by changing these values and seeing where we get stuck. So I think firstly we can look at fixing that the first section of the second section of the first quadrant. So that's changing these values. So at the moment the slope is y over x, and that's because if we look at this again, just I'm going to zoom in a little bit on this. There we go. So if we look at this again, we can see that for all the angles from this to 45 degrees in this direction, y is smaller than x. But then we cross a point. Once we cross the 45-degree point, we reach a point where actually y is bigger than x. So that means now our slope is actually the x over the y, not the y over the x. So that's where we need to come into here, and we need to change these around. So it's pretty easy for us to do. I'm just going to knock it down 1 notch. There we go. I'm just going to take this value and put it on this side of the equation. Hopefully you can still see that. If it's too small, let me know and I will knock it 1 notch. It's just there's a lot of width to these lines, so um, and it's the same on the MSB as well. Wait, hang on. Why is the MSB and the LSB the same? They definitely should not be the same. Oh, okay. It really doesn't matter, I don't think, because I think it should have this in. But because the slopes are the difference between a slope that's 2550 and 255255 is minuscule, so you barely notice it at all. But I will correct them, so they are actually correct. There we go. This needs to be same as that line. Let's just copy those. It's probably the easiest way of doing this. And change those angles. Change those symbols. There we go. Okay, so now this is the slopes going the other way. Now, other than the slope, does anything else need to change here? Well, no, because the line is still x1 and y1. The major axis is the y, but the y is going down the screen. It's still positive, so the y is still positive here. So we will need to change the slope type. So this probably isn't going to work still. We're going to get some weird distortion on this second half of this rotation. Yeah, you can still see it's doing a strange glitch and rotation, like stretching as it reaches that second part. And that's because what we need to do is we need to fill in this value here, the slope type, and we're not setting that up at all at the moment. So let's go and grab another table here. As I say, this is why these need to be optimized, but we'll come to that at some point. and we need to fill this with some values. So each segment is there are 8 segments in this rotation. Each one is 32 bytes long, and the first one is going to be our basic x direction slope, which is this set to 0, in a positive direction, which is this set to 0. They're all going to have this bit set because this is the line fetch or the line draw bit turns it on. And then I'm going to fill in this one here, which is the second set, this one here. This is positive in the y direction. So we need to set this bit here, which says positive y. So I'm just going to put at the end of here what these are. So this is x positive, y positive. Now, thankfully, we'd already calculated these in one of these routines. So I'm going to open another file. Just going to put it over here and see if I can find that chunk of commenting that I did that I list. Or hopefully it's in here. Oh, don't tell me it's not. It's not, is it? Damn it. What did I do with it? Put it in here. There we go. Okay. So you can see here we've got x positive, y positive, and that's what we're showing here. And the other thing we need to know is which end of the line do we draw it from. So at the moment, this is being done because everything's being drawn from x1 and y1 to x2, y2. And so this will hopefully this will work once we wire this up. But as we approach this segment here, things are going to change. The slopes are kind of the other way around, but the most important thing here is that the line goes from the opposite end. So we need to switch x1 and x2 over. That will happen. I'm not sure how that's going to happen. We'll probably do that with a table as well. Could maybe even include it in this slope type somehow, because there's a lot of bits that aren't being used in here. So maybe we can put it in there. But for now, I'm just going to fill the rest of this table in. It doesn't really matter what I put in there. We'll fill it up as we get to it. As I say, I don't care about the size of the tables yet. We'll try and reduce them over time. Is that not 75% yet? No, it's not, is it? What would 75% of that be? Can't even work that out. Oh, it's going to be the next one, isn't it? I guess, yeah. Yeah, it's going to be the next one. Anyway, cheers, guys. It's actually not bad with the kiwi. The grapefruit one's not good, or tropical fruit, but it's got grapefruit in it, which makes it worse. So when we set the slope MSB, let's go and set the slope type as well. Slope type is already labeled in here, so it's easy for us to change it in the job. And there should be a slope set up somewhere, which is here. So let's set slope params. You see, by pre-calculating it, all we're doing is we're just looking something up on the table, which makes this super quick. And when you're doing this on every single horizontal line across the screen, this all adds up a lot. And actually, the majority of the time that you can see in that grey bar is not the DMA; it's actually this code. That's where the majority is happening. And actually, you can see that where the problems are coming in, because the slopes are wrong. It's getting the wrong lengths. It's getting all sorts of things wrong. Yeah, there you go. I think you knew that anyway. Oh, filling. All right. Damn it. My let me change that. I'm going to change it, but you're not gonna know. But you're not going to see it now, but you'll see it next time. Oh, god damn it, yeah. Oh, well. I do my best. I know it's not good enough, but I do my best. Are you currently drinking alcohol? Yes, I am. I did. So did my wine. Monty Python reference there. Like it. Okay, so hopefully now with this sloping, we shouldn't see the grey bar wiggle around. It should be more static, because the angles should be consistent. The length of the lines should be consistent. Um, oh no, it's still. Oh, it's doing something very odd there. Okay, so let's take a look at that. If we go into here, what should we see? So if we're facing this way, let's get into the same position. So it's kind of down here. It's round about here, I think, is what we're looking at. As it moves this way, yes, that line does get longer, but it doesn't get longer in the way that it's doing there. And in fact, we should start seeing the end of the road over there, but we're not. Okay. Store fetch type, slope type X, fetch job slope type. Okay, well that should be setting the right values. It should definitely be setting this value in here, and we should be enabling the Y direction. I don't think it's Y negative. It's not. It's definitely Y positive, so that should be fine as well. But for some reason, it's not showing the right value. Ah, now, is this because these need to be... Hang on. So this is an X over... So this is taking the shortest over the longest, but we need to go backwards. So actually, this would be 1 minus 1 minus, I think. I think that's correct because our value goes from 255 to 0. So let's try that. It's going to be... Oh, that was the wrong file to open. Oh, I should have kept that open, though. I mean, see, it's now actually drawing the track. That's kind of funny. Still something odd going on there. I'm not entirely sure what it is. So let's set the angle and just leave the angle. So let's not do anything with the angle. Instead, let's do the... actually, let me copy that. Let me undo. Okay. So we're going to move through the Y position, but we're going to point the camera in a few different locations and see what's going on. So if I set the slope to something within range, it looks kind of what you'd expect. So yeah, we're moving through the track. It does look a little bit skewed though, so I might need to fix some of the slope angles here, but it is kind of working. It's what you would expect if you were pointing the camera in that direction and then moving in a different direction. But there does appear to be a slight skewing going on. It's probably down to the precision. But that looks all right. If we go halfway between that, let's have a look what that looks like. Yeah, okay. So it's kind of doing what I would expect it to do with the camera turned. I believe there is a little bit of skewing going on that probably shouldn't be there, but we can think about that shortly. So now I'm going to try and do is just move one notch further than the first run that I did. So this is basically just over the 45-degree mark. and see what we get. And there you can see it's definitely is looking very wrong now. Something is definitely not right. We're getting some odd distortion. So let's go and have a look at why that might be. Okay. So first of all, dx and dy's, they're not going to change. Nothing in these would change. Our near and far things. Okay, so one thing I was thinking about is at the moment we do our near calculations, we have a near plane which is at 1. And I was thinking, is there really any point in having this near plane at all? So maybe if I simplify that, we can simplify a lot of these calculations and solve some issues. So let's, before we continue with the rotation, let's try and simplify that and then come back to these ones. Actually, before we do that, I just want to see what it's like without the 1 minus and see which one looks the most right. It'd make elite scrolly. Yeah. See that? But that's definitely scrolling more accurately. But I think what's happening is it's skewing as you go along. It's skewing more and more and more. So I think there's definitely something wrong in the maths again. Awesome. But we'll come to that shortly. What I'm going to do is I'm going to try and reduce the amount of right. First of all, I'm going to save this entire thing. I've not actually got it as a. Actually, I'm not going to save it as a source tree. I'm just going to copy it and paste it for now. I know it's not ideal, but I just don't want to lose anything that I'm doing, and I don't want to commit this yet. So I'm just going to copy paste. I'm just going to make a raw file out of it. 65. So I mean, to give you an idea, this engine itself is probably going to take a little while to get right. But once the engine's right, the rest of it is going to be really easy. So the homebrew SNES development scene has really taken off in a big way. I'd like to do some SNES stuff one day. I'd really like to have a go at that. I certainly could add it to my my framework, but yeah, yeah, I do that as well. But I'm just going to create a raw file now of these things, so you can see the way we're moving here. But if you look at the edges of the screen, when the coins appear on the edges of the screen, they look weird. And if you look at the colors of the track, you will see the the red, yellow, green, and blue. They seem to do some weird color shifts or something. Something's not quite right here. But let's try and reduce this down. So if we didn't have this near plane, if this near plane was 0, let's go and put the angle back to 0 again. It's time to try and simplify so we can make the changes easier. So with the near plane of 0, things still look exactly the same, right? Nothing looks different. The fact that the near plane was 1 before and it's 0 now has made virtually no difference. I certainly can't see what they are. So series 26, can you slow down the moving? Yeah, sure. What's it doing at the moment? Okay, it's decreasing every frame. I'll just do it every other frame. So such an iconic tune, this. Oops. There we go. Makes it easier to spot glitches. Yeah, it does indeed. So the one thing about this routine, and you can see this with the coins. So watch the coins that you see, these coins that are coming up to you now. Watch what happens when you see coins in the distance. You'll see them flash on and off. And that's because they're basically appearing in between the scan lines. So unless they're being picked up on every frame on a scan line, they will disappear when they don't, right? So what happens is the ones that are in the real far distance where the scan lines are really far apart, they will look like they're flashing on and off, and you get it with any thin object that fits between those lines. So that's something that's kind of difficult to fix. With a bit more power, what you can do is you can create kind of interpolation um, between different frames as well, between different scan lines. So you can kind of create a more static version of them. Um, Looks very near. Yes. So the other problem, and this is one of the problems we've got with the current system, is that the the current system allows you to draw or fetch a line from a given area in memory, and you can also set you know, every pixel this way, we move this many pixels this way. But what you can't, what you, well, I think you can, or we just need to figure it out. And this will be something that we can look at later. At the moment, we're setting those values to be spot on that pixel. So if we start at this pixel, we're starting exactly on that pixel, not that pixel and 1/3. We're starting on that pixel. Unfortunately, our dx dy for all the various angles are fractional values, right? So some of them start at you know, pixel 1 1/3, pixel 1 and 0.21 or whatever, and we're not accounting for that. And so what happens is as the lines move down the screen and those kind of sub integer variations happen, we see the pixels kind of shift left and right a little bit, um, which is fine. I fully expect that to happen until we optimize it and fix those things. But for now, my focus is more on getting this to work, to get all the rotations and stuff in, and then making things clearer is the thing I will do once we get to those. No, I don't need to interplay. What I need to do is so there is another value in the DMA. Um, where is it? This one here, the initial LSB and initial MSB. So when you set the slope, so when you set how much for every pixel on the major axis you move down on the y-axis, you can actually set the initial value, the initial fractional value there as well. So instead of starting on an integer here, even though you're on an integer on the x-axis, you can set a variation on the y-axis. So in theory, it should solve these issues, or mostly so, or at least make them less of a problem. But I deem that as kind of a minor thing at the moment. The fact that this is running like this at all is a major milestone, and I'm pretty certain if we were to make a kart game with just this, it would be absolutely fine. Nobody's going to complain about it. But obviously, I do want to try and fix those. That shake that you're talking about was one of the things that I fixed in this version. Previously, there was shake on everything in this, and that's been removed now through proper dealing of the rounding on these. It's basically, it comes down to a rounding error. So what's happening is we're essentially flooring the values that are used to decide the start and end of the line here. In the Mega65 one, and the same thing was happening on here. But what I realized was it's all right to floor the values, but it's where you floor them. So you need to try and keep them as floating points as long as possible, and then you can floor them. As for the coins flashing, you can see it's the same on here. So if I get to this point, you can't see the coins in the road, and that's because if you look down here, probably can't see, but the coins actually fit within the scan lines, so you never see them drawn to the screen. That's going to be a difficult thing to do, because that would involve having additional scan lines. And then, in other words, for every scan line you draw, you actually take two scan lines and you interplay between the two values of the scan lines. So that's basically doubling the resolution. We can get the opposite effect if we change our vertical resolution here. So you can see by taking less scan lines, we can make the coins disappear. So the resolution looks worse as we move this way, but you'll see that the coins disappear because it's taking less lines. So basically, you would do the opposite. You would super sample the track, where you would scan more lines than you needed, and you would just average. You would take the interpolated value between two lines, but that's probably going to be overkill for the Mega 65, and certainly would slow it down quite a lot. So we're not going to do that right now. As I say, the main concern now is getting the rotation working. Once the rotation works, we pretty much have a working game, working engine anyway. Um, you can fix it by increasing the size of the coins. Yes, I mean, yes, you could, but you're even down here, you're going to be in a situation where this point here, I can technically see the coins here, um, but how big would I have to make them to stop them flashing? At this point, they'd have to be 8 times bigger or so to stop them flashing in the distance. All you're doing by making the coins bigger is making them flash for less time. They're always going to flash unless you make them the width of the track, right? Or whatever that is, the distance between the furthest and the second furthest scan lines. Unfortunately, that's a downside of the way these engine works, and I think you'll probably find as well on the SNES Mario Kart is probably still does the same thing. I don't know though. I've not really looked. Let's take a quick look. Where's the coins? Yeah, so it's kind of hidden on this because they've got a lot of texture on the track here, so you tend not to see it very much. But you can see that the resolution is not great. But it's definitely got the same effect. You can see the lines disappearing and stuff. So it's not something I'm hugely bothered about. I am more bothered about the kind of the smoothness of the lines, so that the pixels don't move left and right. If you were doing this on a PC, then absolutely you would do the super sampling approach, and you'd probably scan maybe 5 or 6 pixels, 5 or 6 lines down the screen to be Mario's resolution. Oh, the resolution on Mario himself. Yeah, because this is probably the 1-to-1 scale here. Um, because why wouldn't you do him at 1-to-1? He's the main one you see on the screen, but the other ones will be scaled as they move in. In fact, I think these are pre-scaled because if you look at the well, I forgot what they call them, the womps or whatever they're called, these big blocks that come down. They're definitely drawn at different scales. So is it half speed in Mario? It might be on like 50cc or something. I'm not sure. Or do you mean the frame rate? Yeah, that's the other thing as well. I'm aiming for 50 frames a second here. I don't want to half the speed of the update. I definitely want to maintain the 50 frames a second thing because I think that that's going to be 50 frames a second is going to feel really, really nice. And I think it would be a shame to lose that. And we certainly have the power to do that. So I don't think it's worth kind of sacrificing that speed really, even though we do have a buffer which allows us to do that. We could take so the pink bar there, the buffer that draws from the buffer to the screen, we could do that every frame, or every well actually no, you would do it every other frame still. You do that every other frame, but you could constantly be updating the background. So um the Mega 65 is 50 or 60 hertz. You could do it on either. I use my Mega 65 in PAL mode. It's what I'm used to. I prefer to have more time in the border to do things. I think that's what most people are gonna. I think it's also the default now on the machine. But you can switch it into 60 hertz if you want. You have a switch to do that on the fly as well in the game. But yeah, you can see that. I think the resolution is lower as well. I think the resolution is the same as what I have now. Um, And actually, I think there might be some jittering left and right as well. I don't think they quite have the smoothness spot on. But we'll try and reduce that right down as well, so it'll be better. But anyway, that's kind of what we're aiming for, something along those lines. The only thing that makes my track look bad, even on this kind of JavaScript version, is that I just scaled the image down to 512 and it kind of lost some of the detail, because these were kind of pixel level kind of details. It's kind of lost some of it. So anyway, let's crack on. Let's get onto the right screens up here. What's that? There we go. There we go. That's the right screen. No. Okay, so let's try and figure out what's going on with the slope. So the left and right, sorry, the first 45. Oh no, we're not doing that. We're sorting out the near plane. So if we set the near plane to 0, that changes a lot of these calculations, right? So we have a look down here. The first thing we note is that these are all near, right? And what these are near and far offsets. And you see here, near, offset are all multiplied by our near plane, which means no matter what this is, the answer is always going to be 0. So we can get rid of those because these values are all going to be 0. All of these are going to be 0. All of these are going to be 0. In fact, everything in here is going to be 0. So we can get rid of that entire block there. That also means that these are going to change, because now instead of it being far minus near, it's just going to be far, which means we don't need the minus near on here at all. So minus near. Wait, why is that times 2? That times 256 seems like it's in the wrong place, but wait, hang on. Where's the other? Oh my god, that was wrong anyway. But yeah, that simplifying this is, first of all, it's going to fix that, but it's also going to make it work properly as well. Make it simpler. So this is x far minus near. Again, don't need that. We just need to know this far, is it positive or negative? Set these values. So we do the same on here. So I'm just going to go through and do these quickly. Basically, this is just simplifying the math because we're using a 0, which allows us to kind of basically get rid of large swaths of the math. Always good if you can reduce one of the values in an equation to 0. It usually simplifies things a hell of a lot. Unless that value happens to be on the bottom. If it happens to be a divisor, then you run into problems rather than solutions. And you can do all sorts of weird things like prove that 1 equals 2 and stuff like that. So I say prove, I mean that in quotes, because you're not actually proving that 1 equals 2. Your problem is that you did a divide by 0. I could go into that, but I'm not going to. If you want to know what I'm talking about, just do a search for prove 1 equals 2, divide by 0, and you will see. You'll see what I'm on about. But yeah, this is why divide by 0 is bad, basically. Okay, so we've removed a lot there. So now what we need to do, we need to go through and just make sure that we fix all the things in here that would be zeros. So what we've removed is the MN1s and MN2s and on all that lot. So there's none of that in here. So this is all the same. This uses DX1 and DX2, and they're pulled from those. Division by 0 is good. It's creative. It's definitely creative when you because it's very easy to one of the tricks in maths, or one of the things to look out for, should I say, in maths, is avoiding simplifying equations that end up with you dividing by 0, because it's very easy to do things. It's very easy to shift things. And then end up with an equation that essentially is telling you that you're divided by 0, and then from that point on, your equation is going to be wrong and it's going to do strange things. Insisted that infinity and 0. Well, that's interesting, because you can kind of prove that with limits as well. So limits can kind of prove that infinity and zero are the same. But they can also prove that minus infinity and infinity are the same as well, which is obviously bollocks, right? Because they're they're at opposite ends. But there's all sorts of weird shit that you can do when it comes to infinity and stuff like that. So yeah, but no, I mean they're not the same. Well, what it tells you is that limits are just that. Limits tend towards something. They don't mean that that is the very last thing. So, for instance, the tangent of an angle will approach zero, but it never will be zero. So, uh, divide by zero. No, it's not infinity. It's not. It's neither, because divide by zero could be infinity, but then it could be minus infinity. One divided by zero, right, should be a positive number, right? So you would say, oh well, how many zeros are there in one? There's an infinite number, so then the answer must be infinity. But if you got minus one over zero, then now the answer is minus infinity. So how can dividing something by zero be both minus infinity and infinity at the same time? It's it's no, it does. It's no, 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 no. um, yeah, and that's the thing. You once you use the term infinity, you can't do normal maths with it. It becomes different. So um, yeah. Anyway, let's not get into maths. Yeah, the correct answer to what zero is it's undefined. That's exactly what it is. Meaning we can't define it. We can't say what dividing by the answer to division by zero is, because it conflicts itself. Sometimes it can be minus infinity, sometimes it can be infinity, and that means it can't possibly be. In fact, I think when you do a divide by zero, you can prove that both answers are correct, and that's impossible. So you do in perspective. Yes, and indeed, and in fact, one of the things you have to do with this is you have to make sure that you change some of the values slightly to avoid a division by zero. So yeah, figure out if infinity was 42. Is zero even or odd? I mean, technically it's even, right? Because if you add one to it, you get an odd number. But I think that's another point of contention as well. I think there's some argument over whether it's an even number or not. But I think, of course, it's an even number. This doesn't make any sense for me for it not to be, because if you add one to an even number, you get an odd number. If you add one to an odd number, you get an even number. Yeah, yeah, exactly. Yeah. Anyway, let's crack on. So we want to remove all references to mn. And here we go. Here's some. So this is actually a nice one, because this is just adding some values, right? So this is just adding. What is it actually adding? It's adding our near plane to our position. So this is our point x1, and actually is this in? Yes, this is all in one thing. So basically we're removing this section here. We don't need that anymore, because our near plane is just position. This is just where we are. So this bit here doesn't need to happen. What it's doing is it's adding this value and then storing it back in this thing again. So we don't need to do any of these, but what we do need to do is we do need to load the very last value, the MSB here. And if it's negative, then we need to set this third bit up here. Oh, actually, it's already set here as well, so we don't need to do that. Hang on. We don't need any of this. This is all perfect. 0, 1, 2, 3. So we can get rid of that thing completely. Okay, let's do that. And then this is using parameters x and y for position. Okay, cool. So that's a whole chunk we get to remove out of it. So we get to remove this entire chunk here, which simplifies those. And see, this is why setting those values to 0 makes this a bit easier, right? Because this, we get to remove a whole chunk from these. We get to remove a load of tables from these. But the end result should be exactly the same. So this is, in theory, this should produce the same effect on the screen. So could if it would load. Oh, what's it not loading? Missing start token. Oh my god, what have I done? I've deleted a random bracket somewhere. Oh, it's going to be one of these. Okay, so 1, 2, 3, 4. Okay, so these need an extra one on the end. Hang on, is that there's a lot of brackets going on here. Let's check this out. Okay, so angle, get, yes, I need that. Need the oh yeah, I do. I need all of them, fair enough. But the tables are reduced massively now. I've removed 12. So I've moved 3 kilobytes of tables and quite a chunk of code as well. And I would expect this to run exactly the same. Drums, will it work? Yes. And there you go. So cool. We've reduced the code time a little bit. It's kind of hard to tell, but the gray bar is a little bit smaller now as well, so that's good. So reducing that has actually made quite a big impact on it. Okay, and it also means we don't need this near value anymore. So now we've just reduced the number of constants we need. These constants here are calculated from these ones, with the exception of this one. Actually, that's not. But these ones here, these bottom two, are calculated from these ones. So I don't count these. These should probably go into one of these files somewhere. And what I'm probably going to do is have another import called mode7, which imports both of these and these constants, so I don't have to worry about that. So I'm going to group all those together. This will be another file somewhere, and you'll just import mode7. But so far, this is looking like it's working, which is pretty good. Doesn't seem to be anything broken. We've simplified that quite a bit. Our table's a lot smaller now. Yeah, we're using what's that, 5K instead of 8K now, so that's pretty good. And I still think we can reduce this further with these slopes as well, but we'll get to that once we fix the slopes as we go around. How can they turn this around if you lose all the tables? You banned from 2 casino chains because you worked on their IT systems. Yeah, casinos can be funny about things like that. Like, for instance, it's not illegal to count cards. It's perfectly legal to go into a casino and count cards, but they won't like you if you do it. They will, they will kick you out if you do it. But it's not illegal to do. But they reserve the right to kick you out at any point. So, but what most casinos are pretty good with, I don't know about in the UK, but certainly in the US, casinos will allow you to take the kind of blackjack cheat sheet to the table, so you can have the thing that tells you when to split and when to hit and stuff like that, because there are some combinations that aren't immediately obvious. Most of them will allow you to take that to the table, because that's not really cheating. You're not card counting, you're just playing the perfect game. And even if you play the perfect game, if you're not card counting, you will still lose in the long run. So if anything, they would like you to do that because it will keep you at the table longer. You're more likely to spend all your money, whereas if you go on a very, like, a quick burst of losing, yeah, say you lose half of your money in the first 10 minutes, you may just walk away from the table. But if you lose all of your money over the course of 8 hours, then they're happy with that. So yeah, you will lose. You will definitely lose. Yeah, perfect blackjack strategy. It's more than that. I think it's like 99% or something crazy. It depends on what the so some will raise the number, or lower the number that the dealer will stand on or hit on. And some have different rules for, like, they'll have like 3-2 return on if you both get blackjack. Some will do I forget what they call it now. Is it push? I think, where you just get your money back. Some will give you a 3-2 return if you both get blackjack as well. So there's it depends on the exact rules, but I think the standard rules is something like 99% is, which is why a lot of people like it, because you can sit at a blackjack table. And this is why I play blackjack when I go to a casino, because if you play the perfect strategy, you can sit at that table for hours and hours and hours, and it's fun. It is kind of fun, especially in Vegas, because you get free drinks. You're losing, a couple of dollars an hour, maybe $20 an hour. But in that same hour, you've had like 4 Jack and Cokes, or so it's worth it, and you get the experience of sitting at a Vegas blackjack table. So yeah, which is why they don't like you counting cards, because the moment you start counting cards, you do have an advantage. But most casinos are kind of wise to it, and they have ways of avoiding it as well. So one of the tricks that they will use is like the simplest thing that they can do. Got no ice in this drink, so I'm just going to dump the whole bit. Is to use multiple decks. So they'll use like 8 decks of cards to make it a lot harder for you to count things. And yeah, the other thing that they'll do, exactly what Warlock says there, is they usually the croupiers will have like a little display, and sometimes the people in the pit will press a button to say, you know, shuffle the like redo the deck, or it will be automatic based on how many cards they pull out. And they can, they could only use maybe 10% of a deck before they shuffle it again. So in that case, your card count is not going to go very far at all. It will still give you a little advantage, but not a huge amount. And you'd be surprised how easy they can spot card counting as well. It's not like they don't sit you. They don't look for you going, well, count it out, or even count in your head. They look for betting patterns. Most people at a blackjack table will bet the same amount every go. If you're betting like the minimum amount, and then all of a sudden you bet like a shitload, and then you bet a minimum amount, and then all of a sudden you bet a shitload, then that betting pattern is going to raise suspicion. And those things are monitored quite a lot. Anyway, enough casino talk. This is Gihaf series. This is one he sent me today. Both the series I got today, the one I got from Andy and the one I got from Gihaf, they're good series. They're going to be difficult to get them all anyway. Okay, so let's have a look at this slope. Now we've simplified things a little bit. So the problem is we're trying to get a line that we draw. If we were drawing the line, which we're not, we're fetching it, but let's say we were drawing it. We're currently looking at this angle here. Let's just get this. We're kind of looking like this. And what we should see as we turn this way is that. What I'm going to do is I'm going to move us over to like here or something, so we can see these. I'm going to do it. Actually, I'll tell you what I'm going to do. I'm going to move us to this line here. Like so, because this will allow us to see another line appearing in this direction. So I'm going to grab that position, which I can get from here if I do map view. Map view dot. What is it now? Position, is it? Yeah, map view position. So 103, 199, and 128. Okay. So the other thing here is the angle is the opposite of what we have on there. But what was it? 103, 199. So I am going to use decimals here, just because that's what I've got from the thing. I'm going to put angle as decimals as well. Don't normally do this, but for testing purposes, it's kind of easy. Okay, cool. So, and then what I'm going to do is I'm going to get rid of somebody shouted outside. Tell you what, you can tell when this country starts drinking again. The noises start outside. So we're going to move back to moving the angles. And there you go. You can see there's some serious problems. In fact, it looks a bit weird in the normal angle. Let's just put the angle back to normal. It looks like when we go back, it screws things up. So So that's fine, but there does seem to be a little bit of skewing going on. That is a strange thing. So I don't know if you can see that, but it definitely looks like it's skewing. Let's slow it down a little bit. Let's put this here. Okay, should be back. Hopefully. There's some serious shout going on outside. Yeah, I don't know what happened there. OBS completely died on me. Very weird. Okay, it looks like something's not quite right with this because it looks as I move like there's a weird skewing artifact going on. So I'm not convinced the slope is actually correct here. So let's just take a quick look at what we had in this original routine and see if I'm missing anything obvious. So this was our accumulated values. Okay, so there was definitely this -1 thing going on. So I'm going to try. Where would that be? That would be in this section here. So this is our slope, basically. Oh, wait. This is. Wait. This is doing. Oh. Well, this is just giving us a value from 0 to 1, right? Because this is taking the smallest slope over the biggest slope. So we're taking this value. I'm going to put another one of these at the beginning of them all. And what we need to do is we need to times this by this. And then that will give us a value that's actually a slope this time. So this should get rid of the skew. Because at the moment we're only using this, the first 32 here. So I'm hoping this fixes that, because I think what's happening is instead of it rotating, it's just skewing stuff as we move across. Oh my god, there's some real shout going on. I think somebody's having a fight outside. Okay, so somewhat better, but still definitely something weird going on. Okay, let's ignore the LSB for the moment. That's just our precision, right? So let's ignore the precision. Let's look at this. So if we just take this upper value and we do this by 255, so now we've got a value from, and this is an ABS value on both sides. This is a positive value from 0. Yeah, so this is taking the length of the Y over the length of the X. The X is always bigger. Oh yeah, let me start the quiz again. Sorry, guys. Yeah, I have no idea what happened there. It was very bizarre. Anyway, we're back now. Hopefully, it might fix the lag issues. What's everybody's lag like? that hot dog looks good, actually. Oh, I tell you, I've not had for a long while. I need to order some again, some currywurst. Big fan of that stuff. But we always have a fried egg on top. Okay, so I think it's something to do with this slope not being right, because we weren't looking at the I feel like it's still skewing though. I don't feel like it's rotating properly. I can't actually tell. Let's bring up this and have a look what happens if we rotate this way. Okay, well maybe it is correct actually. Let's get to the exact spot. So we're kind of like here. No, it's not. It's skewing, and the reason I know it's skewing is because if you look at that horizontal line in front of us, look at what happens on this screen. It starts sloping, but it's never sloping. It's just sliding across. It's never sloping. So that is not happening, right? You can see on ours, it's this line in the distance. This one here is never sloping. It's just saying, yeah, it's not turning the horizontal line exactly. Yeah. So the slope, it doesn't seem like the slope's doing anything. That's weird. All right, let's think about this. So this is taking our far point on oh wait, x, yeah, our y, the difference in the two y's and the difference in the two x's is taking the y over the x. And in this case, it's doing angle 1 over angle 2, 1 minus 2. Actually, this doesn't matter either because we're using ABS. So this is going to be the same regardless of which order we do it in. So that's fine. Divided by ABS, blah, blah, blah. And then we're timesing the whole thing by FF. So this should give us a value from 0 to FF, right? So when the y is small, which it is when we're pointing straight up, then this value would be 0. And at the other end, it would be FF. And this should be being copied into here, to this value here. So if I just set that to FF, then we should see that that slope is, let's just get rid of, oh, aha. And can you see the bug? I'm an idiot. I don't know if you can see that bug, but I'm copying the LSB into the MSB, so that was wrong all along. Okay, so I think that should be right now. So that was the problem. We were never actually filling that value properly. Boom, there we go. You can see it's now turning properly. Excellent. So bug fixed. We move on to the next section. So now we need to work out the angle for the next section. So let's increase the distance that we're going to move. Also, is let's put the accuracy stuff back in. Hey Hayes, thanks for the resub as well. Cheers. Okay, so let's put that calculation back in. So let's make that larger again. We'll leave that the same up there. And now we should have a slightly more accurate turn, although it doesn't look bad at all. Really doesn't look bad. Yeah, they're crazy gambling addicts. It's ridiculous. It's super ridiculous. Okay, so now we need to do the opposite. So we need to get the x over the y, which is what this is doing here, times FFF. We'll do the same on this line here with the minimum. And then I think all we might need to do here is do 1 minus before we do the multiply here. So it would be like here it'd be 1 minus. I think I'm going to put it in. If it's wrong, then we'll have to change it. This is where it's going to get tricky. As we move into each segment, it's going to get tricky. There's going to be at least one piece of code that we need to put in to switch the points around. So px becomes px1 becomes px2, py1 becomes py2. We only have to change the px and the py. We don't need to change anything else. But we may need to change those values at some point. And I'm hoping we can define that with a table. I think we will be able to do it. Well, define when to switch with a table anyway. So let's try that. I will play a bit more Resident Evil as well tonight at the end of the stream. Okay, no. Okay, no, it goes horribly, horribly wrong. And starts breaking. Okay. So let's get rid of the 1 minus. Maybe it's not 1 minus here. Let's just see if that works. I have a funny feeling this is not going to be super, super simple. But I was fully expecting this. I'm glad it's been simplified, though. That's... Oh, but then it breaks there. That's the funny thing. It doesn't get even all the way through this, and then it breaks. Which is weird, if I'm honest. It is strange. So if I do like halfway through that segment, wonder if the pseudo 3D effect will work for anything. Yeah, there's a few games that that did use it. Wait, why does I only get... Oh, because I've done and... Okay. Yeah, there were a few games that used it. I mean, you could have a kind of exploration. You could have some kind of world exploration. I don't know how, if you combined it with a bit of 3D as well, and there's definitely room to do that. If you look at the raster time, I mean, there's enough room to do that. Did Pilot Wings? Yeah, I think it did actually. Yeah. There's quite a lot. There's a lot that could definitely use it for sure. Okay, so what are we getting wrong here? The slope. Okay, so the slope needs to go the other way, right? So at the moment we're going from 0 to FFFF. So what if I take... No, because the problem is when we point at that angle, we're looking at the wrong thing. We're looking at something completely wrong. If I get rid of this bit, right? What we should be seeing is we are trying to point in this direction. That is kind of what we should see. But what happens is we see something completely different. If I go and set the angle, so I'm setting the angle to... What would it be? It would be like 63 here. Which in a circle with 256 degrees around it is oh, there you go. What the hell is that doing? See how, look, the DMA gets really, really stuck here. Something weird is happening at this point. So let's an inch towards it. So let's go halfway between 45 and 90 degrees. Lunar 3D. So you can see it's pointing in the right direction. So we should be seeing we should be seeing kind of that, and it's almost I mean, it's definitely pointing in the right direction. We're definitely seeing the right things, but what we're seeing is like a weird stretched version of them. So something has ruined the view somehow. So let's keep this static view and see if we can fix it. Let's do that. There's no Doom for Mega65. Doom is certainly possible. I definitely think Doom is possible. After doing this for a couple of days now, I definitely think the routines that are in there now for the DMAs are probably enough to do this. Thanks for the follow, Unidorsal. Welcome to the stream. Hope you're doing all right. You've been working on a version of Cyan Attack on the premise if I use DMA, it will use a feature of the Mega65 that isn't. Yeah, I will absolutely accept that as a new feature. Yeah, Showdown 3D. Yeah, Showdown would actually work on this, wouldn't it? For Raycast. Yeah, I definitely think the stuff we've got here is enough to do that. And it would be, it would, I mean, it's essentially a similar effect, but what you're doing is you're scanning lines down. You're drawing lines down the screen. I mean, you don't have to draw them down the screen, but they're scanned as if they're going down the screen. And then instead of you scanning them by going by taking lines across your field of view like this, instead what you're doing is you do raycasting. You draw a line from your point in the direction that that vertical line is on the screen, and when you find a wall, you say, okay, that wall is 10 units away, so that wall is drawn 10 units high, or whatever the distance would be. You use your perspective to draw it at a particular height on the screen, and then you go to the next vertical line down the screen. You say, okay, if I draw a line towards that vertical line from my viewpoint to that vertical line, when is the first wall that I hit? And that wall may now be 11 units away because it's sloping away from you. So now that line gets a bit smaller and a bit smaller, and that's how a Doom engine basically works. It's a similar effect to this, but it's just the maths is kind of twisted a little bit differently. But and instead of taking scan lines like this, you do raycasting lines. So you draw lines from your point out towards the things. But the essentially the way that the lines are transferred from a texture to the screen would be the same. It's just that you're not scanning on a text. This would instead be a 2D representation of your 3D map, if you like. So uh, yeah, Wolfenstein C. Well, I mean, Paul did Mega Maze. Mega Maze was written in C, which does the same thing. It really wouldn't be a huge stretch to combine Mega Maze and a Mode 7 floor like this and end up with something that could do a proper Doom engine. I honestly believe Doom could be done in this. I don't know how detailed it would be, but I honestly believe Doom could be done in it. But it's a bit down the road that before we get good enough to do that, I think. Okay, so the question is, why are we seeing distortion at this point? And more importantly, why is it breaking when we go kind of too far in one direction? So that's making me think that maybe one of these calculations is causing us an issue, but these calculations themselves work fine for that quadrant. So maybe it's not so much the calculation, but where the start and end of the line is. See here, we're adding a line to the buffer, so we need to work out how long the line is, and we should be working out which the longest line is by taking these values, and we're taking px2 subtracting px1. Oh, and I've just spotted the error here. Look what this is doing. This is the JavaScript code, or roughly it's the pseudo code from the JavaScript. Or if it was, because this actually doesn't happen in the JavaScript, but this is what it should be doing. It should be taking the length y and calculating that, and doing that by taking py2 and minusing py1. But look, it's taking px2 and subtracting px1. So this just needs changing like that, and that should be fine there. This is what happens when you do code late one night. That looks definitely different. Let's try moving that up to 63 angle where we got the black screen. If we don't get a black screen, then we'll try animating it and see how it looks. But that definitely looks better. It looks a little closer to that. We still get a black screen though. Okay. Okay, let's put this back in again. Let's see what happens. I would thought that would have fixed it, but maybe there's more than one place I should be doing that. Probably need to go through all of these and just check that the PYs are PYs when they should be, and the PXs are PXs when they should be. Yeah, see, this is not drawing anything. It's failing. Okay, let's py, yes, minus py1. Okay, length y, okay, and then they should be taking, this takes length x. Oh, if x is longest, it should jump to here. Oh, and len x are the same. Okay, so that's fine. Okay, let's set this back to 0 and see what happens. Yeah, it probably is a copy paste error, almost certainly. No, see, there's another calculation that's going wrong somewhere. Okay. So let's go through each section and make sure that it matches up. This is why it's good to have these bits of code written in as well. So dx1, dx1, dy1, dy1, dx2, yeah, dy2. Okay, these look good. So look at these bits. Okay, so this is working out the view height from the row. This doesn't matter. This is always going to be the same regardless of what our x and y's are, and therefore the depth factor is not going to change either. This is where it starts becoming specific to a particular setups here. So this is dx1, calculating px1 from dx1 and the depth factor. So I see px, so I see x1, 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 x1. Everything looks good. X1, X1. Okay, and then X here as well. Okay, cool. Y1, 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 Y1. Make tables Y, PY1, PY1. Okay, and then X2. X2 is there. X2, 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 and X in here. Okay, so they all look good. Y2, PY2. See, it would be unusual for these to be wrong because these are these really don't have anything to do with which point is bigger or lower. It's at this point where it starts changing. Okay, Linux 0, 1, 1, 0, 1. Okay, so this looks like it should be fine now, but for some reason it's not. We're seeing an issue here. So I'm going to turn off the border stuff color here. I'm going to see what happens if I change border colors at certain points in here. So if the X is longest, then we're going to set the border. So we'll start by default, we'll set the border to red. But then when the Y is longest, we'll set the border to green. And maybe that will help us see if there is a point where this actually happens. Well, I'd say it's not green, is it? It's pink because I've changed the palette. Oh, but I noticed that never actually changed. Okay, so what I'm going to do in that case, I'm going to put a point in here where I increment the border. I just want to see if that's because it may just be that I had two shades of very similar color, but it looks like that border color never changed, which means maybe these comparisons are wrong, and that's why it's failing. So it should break, and it isn't breaking. Ah, there, it broke there. But at that point, it's too far. It's gone way too far already at that point. And that's when this is where it turned black, right? This is where the screen went black. So I think this is happening way too late. So let's just put it back to 1F so I can show something that's working. Stopped watching when he started waving guns around. Yeah, same, to be honest. I always had a funny feeling about him as well, but it wasn't to do with the guns. It was just there was something a little bit off about him. I'm not sure what it was, um, but yeah. Anyway, Okay, so what I want to check here then is length X versus length Y. So I think what we'll do actually, the easiest way to do this is to force what should be length Y bigger and then check those values in memory. So we're going to set an angle somewhere in the middle, 48. And then we could go and check length X and length Y. Now these should, hopefully I can just run this and check those values directly in memory. They shouldn't change. Let's find out where they are. Oh, God damn it, I've not got that labeled, so I can work my way backwards from that. 26F3. So they should be at 26F1 and 26EF. And you can see there's definitely still some distortion. It looks stretched here. So 26EF. So this should be our length X, and this is our length Y. And length Y is definitely more than length X here. So these are the values that we've got. Let's go back up to our code and put them in. Okay, so what we've got is this is our length X and length Y, and they're in little endian format, so switch those bytes around. And you can see X is that. This is the length of X, and the length of in the Y direction is that. So this is our two sides of the right angle triangle. So the distance along the y-axis is longer than the distance along the x-axis. Exactly what we'd expect for an angle like that, which is actually this angle here. So you can see if you look at these lines, there's more. They move more in the y direction than they do in the x direction. So that's exactly what we'd expect, right? Okay, so and I'm going to need a new mixer soon. I might go and get. I might take a short break in a minute to get another mixer and some. Oh, actually, oh no, I've got Fanta down there. It's fine. Yes, I've got Fanta. It'll be fine. Fanta and Coke I've got actually in here. So what we would expect at this point is for this to be the code that we enter here. Except we're not seeing that. We're not seeing that at all. It seems to be jumping to here. It doesn't seem to be doing this. As noted by the fact that the screen is pink, right? The screen is doing this, it's not doing this. So let's take a look at why that might be. All right. So we load the upper value, which is this one here and this one here, and we compare them. There we go. And straight away I can see the problem. Okay, so the problem is here we're comparing if a value is less. So we're comparing if x is less than y. They're not. They're the same because we're comparing the MSB here. If it was, then we jumped here because we know that if this is that and that is that. In other words, if 0 is less than 1, then x is definitely lower than y, and we jump to here. Otherwise, if the carry is set, we jump to x longest. Now, if both of these values are the same, then the carry will be set. So we're immediately jumping to there, even though both those values are the same. Whereas what we should be doing is if the values are equal, we should be skipping ahead and only doing this if the values aren't equal. So if the values are equal, then we jump to here, and then we compare these two values. And it's the same thing here as well. If these values, in fact, in this case, if both values are equal, it doesn't really matter which one we do here. So this is probably fine. But that was the missing part, that missing thing here. So that might actually solve our issue. Let's give it a try. And hopefully we'll see something a little bit neater. So we need to make sure we close M65 Connect because that doesn't like us running builds if we've already got that open. Straight away we get that. Okay, cool. So that means we're definitely entering the right piece of code now. So let's turn off the increment and go back in. Oh, God, it's time to shave my beard. It's making me itch all over. Aha, boom, there we go. That looks correct now. So now let's go in here, turn our angles on. Whoops, step 11 then. So now hopefully we get the full kind of turn as we go around. And we've got the first 90 degrees. Okay, there's a little bit of a jitter there. I'm not entirely sure what that's about. This could be down to our minus values here. That should be minus. So let's try doing that here. So let's do 1 minus here, do 1 minus here, and give that another run. It could just be because our angles should be going backwards at that point, but we're kind of getting there. Oh no, it's still no. It kind of goes bonkers, doesn't it, when it gets to that angle for some reason? Why is it going bonkers though? That's the point. Because it seems to be partially working, but not quite. Okay, but it's definitely along the right lines now. So let's get rid of the 1 minus just in case. I don't know what that needs to be yet, but we're getting there. Better than before. Yeah, and that's essentially what this is going to be. The problem we've got is because of the way the DMA works, you always need to be counting along a major axis in the positive direction. So this is where it kind of becomes complicated, and that's why instead of it just being a circle with 256 different angles that we're going to use, it becomes 8 segments with 32 angles in each one, with each one having a different slope direction, a different major axis, and a different start and end point to the line. So it complicates things a little bit. But as I said about the raster rewrite buffer, if things weren't complicated, it wouldn't be Commodore. So it's what makes it kind of fun to work with. So it's good. Oh, thank you for the cheer as well, Unidorsal. Appreciated. Cheers. Let's just get some active. Which is not going to be cold, but whatever, it's fine. Let's get some more vodka on the go. Okay, so we kind of have something. It's just not quite right. Now, is it because the y needs to be negative? I don't think that's the case either. I don't think so anyway. No, because we're moving positively through the y-axis here, so that shouldn't be an issue for us. Trying to think now. So what would be doing this? We're moving that direction. It looks fine until we get into like, so it's fine, it's fine, it's fine, and then it starts going kind of mental and moving around a little bit. Why is it moving around a little bit? It does seem like it is the beginning and end of the point, at the end of the lines, maybe. I'll tell you what we're going to do. Now we've got those working, I'm going to go through. So the slopes should be the same. Let's go through all the angles. Let's see what happens. See if any look correct. 64 times 4, is that correct? 64 times 4 is 256. Yeah, okay. So let's just go through all the angles and see what happens. See if any of them look correct. I suspect things are going to go awfully wrong here, but oh god, it's doing all sorts of weird things, isn't it? So correct, 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 and then it starts going bonkers. But then it looks correct for a split second. It looks correct again, and then it starts going in reverse. And the reverse is when the axis should switch over. So when x2 should become x1 and vice versa. Okay. A debug view showing the actual, yeah, it would be amazing, but unfortunately, that is going to be, well, not impossible, but very difficult to do. So Um, uh, we're just gonna have to deal with it like this, unfortunately. Uh, Actually, is there a no? It's still not going to work because the image is too big for a start. No, it's not going to work. All right, never mind. I was thinking there might be a way of doing it, but it's not going to be easy at all. So I'm not even going to attempt it. Um, it's just thinking about the maths, right? It's just puzzling over the maths. So let's just get that first quadrant done. So we've got the first half of the first quadrant correct, but the second half of the uh, it's remarkably consistent where it fails. Yeah, it's definitely going to be some maths thing somewhere. And so far, everything has just been kind of slight math problems here and there. It's the fact that it moves up and down like that. So I'm trying to think like what that effect is actually doing. And it kind of makes me think that the y angles are no, it can't be negative. It can't be like that. Okay. Let's have a look through these. So these are our differences. So obviously removing that the near plane has made this much simpler. So this is going to be easier to debug. You can pick up alcohol while driving, and the more you pick up, the more the game looks. Yeah. There's actually some really nice effects you can do. So, like, if you increase the near plane, I mean, we've removed the near plane now, but if you increase the near plane, you can make the road look really curved, like you're going downhill all the time. Um, and likewise, if at the same time you mess with the field of view, you could do some really, really disorienting stuff. Overflow, yeah, it could be. Actually, I'm not sure. Let me check them. Right, okay. One thing that was worth checking here is that the fact that um, the divider should never be using negative numbers. It's not flipping around due to something overflowing back and forth. That's a good point, actually, because it does seem to flick around, doesn't it? But see, it's kind of consistent through the first. Is it through the consistent? I know it's doing it the whole time, so it's bouncing around the whole time in that section. Okay, let's take a look. Let me try the slopes. What happens if I change the slope? So because this will tell us if it is anything to do with that, right? So if we turn the slopes off for this section, which was the skewing, remember how it was skewing before? So now it's going to skew again. But what we might be able to understand is, does it still do the wobble? If it still does the wobble, which it does not, it seems to be consistent the way it works. And that's because now it's only doing the skew. So I mean, obviously it's wrong because it's skewing instead of rotating, but it's not wobbling around, which makes me think this is probably wrong, right? So let's leave the bottom one on 0. Let's just focus on this top one, and let's have a look at what it's doing. So I'll split it onto 2 lines just so we can see. But essentially, it is taking. Actually, can I stretch that over there slightly? Yeah, that's good. Uh, okay, so what are we doing? We're taking the far point at the angle 1, which is left hand, far point at angle 2, which is also left hand. It could be random. Yeah, that's a good point. Or are you talking about the gambling? Are you talking about the gamble? Uh, yeah. So I mean, this is, if you look at the first section, which is correct. This section works. It's exactly the same as that section. How come I do 2 checks for D012 on the freight? Oh, and here, this is just, I mean, this has become habit now with the Mega 65 because the Mega 65 is so quick. If you don't, I mean, it won't matter because I'm doing this in the middle of it all, so I can actually lose one of them. But if I wasn't doing something that took definitely multiple lines, then I could potentially have all of this stuff happen while I'm still on this line. It's so quick. You get 40 times as much time. It's the equivalent of 40 raster lines on the C64. So you imagine running some code that would take 30 raster lines on the C64. It will all happen in one raster line. So then when it comes back around again, this check will immediately allow you to go back on again. So could you do wait for, yeah, you could wait for the yeah, but I don't want it to wait till the bottom of the screen. The reason I'm doing it at the top of the screen is so it's easy for me to see exactly how much raster time it takes. When I turn the raster bars on at the bottom, they can bleed into the kind of off-screen stuff that I don't see, so I don't always know exactly how long they're taking. This way I can see because they're in the middle of the screen. But yeah, I mean, I can get rid of that. I can get rid of one of these now. I don't need to do two because it's definitely going to take more than one. But yeah, you could definitely do that to do the same thing. Okay, so there is no difference between these two slopes, right? This one and this one. Oh no, the one is x over y, one is y over x. That shouldn't matter, I don't think. It has to be x over y because we're getting the slope along the. Oh wait, hang on. Yeah, that's right. We're getting the slope along the x at this point. So we need to know for every y, how many x do we move? And that's what this gives us. So that's correct. And the x y x y x y x y 1 1 2 2. So everything's fine there. The only thing it could be, so if you move one along the y, then how far do you move along the x? Well, it wouldn't be. Oh no, it would be this. This would be a large number. So it's definitely okay. So I've definitely ruled out the fact of doing this. We don't need to do this. This automatically gives us these values that we saw in this. How was it? In this thing here, where the value moves from 255 to 0. That's exactly what this is going to do. This is going to move from 255 down to 0. So this is correct as well. So then slope type, is the slope type right, or is the slope type wrong? Should the slope type be minus? I don't think it should, but let's just try changing it. I'm running the wrong piece of code. No, see, I did something even weirder. Okay, so that's not correct. That's correct like that. Okay. Is the I the same for all calculations of the for loop? Oh, that's a good point. We've got I here, and then we've got I. Oh, that's probably not a good idea, actually having. I mean, it shouldn't override it, but maybe something is breaking it. I wouldn't trust Kick to get that right. So, yeah, that may be an AMK points thing there. But in fact, I'm going to give you that just for spotting that because that's definitely it's definitely worth some points. Yeah, yeah. God damn it, Andy, give me time, man. That's so funny. It's hilarious. Every single time you say something, you do a listen. It's hilarious. It's because Andy's got space internet, and now I think all his internet traffic goes around Jupiter before it gets to me. Not every time. Anyway, yeah, I just awarded some points. Okay. I mean, it's not that, but it's definitely a good point. I should have been looking at that. No, I know what it is. Do you know what it is? I'm going to give you more points because I think you're saying, yeah, you're saying the same thing. I think you Nicomo says the right thing. It's just I misinterpreted it. We need to make sure that we actually add the angle on, because on these ones here we're going from 0 to 255. On these ones we're going 0 to 31, and then 0 to 31 and 0 to 31 again. So I think that's what he means by them. So actually I'm going to give you another 5 points, even though it's the same thing. I think you've oh wait, I gave Andy the points then. I gave Andy points for Nicomo's things. I need to give Nicomo. I'm going to give him 10 points for that. I gave Andy points. I gave Andy points for saying listen too often. God damn you. God damn you, man. Okay, so that means this is right. But yeah, that's exactly right. That's what was happening. The value was the same for all of them. I wasn't looking at the bigger picture. I was only looking at the uh actually, can I do this? If I can do this, then that's nice. I hope I can. I've never tried this before, I don't think. Splitting it over two lines. He does. He's realized that the listen command is great. Need to say no. What I need to do is when Andy does a listen, it needs to do a slightly different sound, so I know it's Andy's listen, and then I can just take longer to listen to it. That's the thing. I've got so used to giving Andy points that you just earn points then for nothing. Uh, Stealing my idea. Well, it's a good idea. Nah, you do a good job. You deserve all the points you've got so far, Andy. You do a good job. You just crack me up. Your instinct to go straight to the listen is kind of funny. Way there we go. Perfect. And it does mean I can split these over two lines, which is good. Now, these are ABS values, so I think actually that these can repeat all the way around. I don't think I need to change these values. So I think this is enough now. But what I probably need to do is this to make sure it fits all the way around. Oh wait, no, that's not going to work, is it? Because no, I do. Hang on, no, because in this particular quadrant, yes, but I think this is probably going to be the same in each quadrant. I think so. I'm not going to change this. I'm going to see if this works. So what happens on the next quadrant? So on the next quadrant, which is down here, we get to the point where y is still the major axis, but x is now a negative slope, which means we're still going to go from 1 to 2 because we go along our major axis here, and our major axis is still running from this point to this point, so our major axis is still 1 to 2. And it is running in the positive diode. So we always move positively along the major axis. This is positive y. And so that's fine. But it means this one here is y positive. Yes. But now, wait, no, y, but negative slope. So what this means is we always move positive in the angle of our major axis, which is this one. The sign that follows it here is which direction we're moving on the minor axis. So we are moving in the y major axis, but we're moving negatively in the x-axis. I think these slopes should stay the same. So I'm now going to increase this. And I think what we'll see now is we'll get to the last quarter of this semicircle before it fails, because this will be x minus, and this is the point where we need to switch the thing over. And there you go. The stretch is happening. It's failing. So good, 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 still good, and then fail on that last bit. So we're failing on the last bit because what's happening is we're approaching this point here. And when we're at this point here, the x-axis is now the major axis. This is the longer of the two. There's more along the x. That's exaggerated a bit. There's more along the x than there is along the y. But also, if we move from 1 to 2, the x is going backwards. So now we need to switch those points over. So at this point, P1 needs to become P2. P2 needs to become P1. But what have we got? We're still going positive in the y. So this is going to be x. Let's put all these things in. So it's going to be x-axis positive. Let's compare that to this. Does it even match this? X positive. No. See, x doesn't make any sense actually. That can't be right. So this one's right. This one is wrong. But I feel like this should just be x negative. Let's see what happens if we do that and run it. But I think what we're going to need to do is switch those points over. Oh, this is negative, isn't it? That's right. No, hang on. Oh, God's sake, we're on the wrong one. This is actually quite a hard background thing anyway. You see there where it's kind of showing a mirror image of what it should show, and that's obviously skewed in a weird way as well. Okay, let's think about this again logically. So let's come to the middle. Okay, so x-axis y positive, y-axis x positive. Y-axis x negative. So we should have, yeah, that's fine. And then x-axis y positive, x positive. Yeah. Okay. So y-axis is positive, and then x-axis y negative, and then this is y-axis x negative again. So y-axis negative, and then this is y-axis x positive, and then the last section is this one here, where it's x-axis y negative. Right, so that should be on 2 x positives, 2 x negatives, 2 y positives, 2 y negatives. Okay, that looks correct. So now the other thing that we need to know is whether or not the lines need switching. So I'm just going to put that in as this byte here, this bit here, the last one. If that bit is 1, then the lines need switching round. So what we're looking for here is in the positive axis, in the major axis. So in this case, this is the major axis. If we treat this side of the cone as we're facing into the cone, if we treat the left side of the cone as the start and the other side as the end, is it going in a positive direction? If it is, this is 0. If it's not, it needs to be 1. So yes, that's going positive. Yes, that's going positive. Still, yeah, going positive, and then this one we're not. So this is this one here, and that's now going in the major axis. So the y-axis is going in a positive, but the x-axis is negative here, so that needs to be 1. And I think we'll find that there's probably just 4 in a row here. So that was this one here. because yeah, that one's still X major, Y positive. That is X major, Y negative, which is this one here. Wait, no. No, hang on. Oh, fuck's sake. Start in the middle here. Okay. So this one. X positive, Y positive, yes. X positive, Y positive. Oh, and that one as well. There we go. Oh no, because the Y is positive there, so that's fine. Here the X is so okay, that's the first one that needs to go backwards, which is correct, but the Y is still positive. And this one, the X is still going backwards, but the Y is also going backwards here, which is this one, so it's negative, but the X is going backwards, that's correct. Then this one, the Y is going backwards. And then this one, the Y is going backwards, and then we get to this one with the X. Okay, yes, that's that one and that one. Okay, cool. So these 4 bits here on the end tell us if we need to switch the lines over. So let's go first of all and sort slope type out. So this is being red here. We just need to AND that with that just to turn that bit off at the end. We don't care about that bit right now. But what we will need to do before we work out the start and end, which we work out here, we need to figure out which one is the actual start and which one is the end. But before we do that, we need to figure out, is it this one here? Oh, no, we can do it after because the length is going to remain the same. Is it? No, because... Oh, no, this is negating the line. So this is taking the ABS of the line. Okay, so that's fine. Takes the longest line. That's fine. So we can do it here. We can actually do it as part of this. So what we're going to do is we're going to take our slope type and we're going to AND it with... if that's equal to 0, no switch, which is going to be here. Otherwise, we need to switch some values. And the values that we need to switch are really easy. They are px1 with px2. So we're going to take load x with px1, and I'm going to store that at rest. Call it rest px. Beef like that and store that in px2. Okay, so that switches px1 and 2. Now we do the same with py and 2. There we go. Right. Let's see if that's changed the way this works. Maybe not. It's probably going to be completely wrong now, but let's take a look. Okay, no, something's gone wrong there. Oh, I'll tell you what's gone wrong. It's because I've not filled these values incorrectly. So x-axis means this is 0. So 0, 0, 0, 1, 1, 0. So y, 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 1, 1, 1, 1. And then if it's negative, these ones need to be 1. It's positive, then it needs to be 0, 1, 1, 0, 1. There we go. Let's try again. Oh. Oh, something. Which quadrant did it go wrong in then? I wonder. It's that third one. It's this one here going wrong. where the point should be switched. Okay. So what I want to do is I want to try going all the way around, see if any of them work. I have a feeling the very last one will work. So the one just before the due north, these are all going to be backwards. And oh, actually, yeah, no, they're going backwards, aren't they? It's trying though. It's really trying, and then this one should be right, which it is. Okay, so it's when these points need to switch over. So it's these ones here. But we're almost on the right lines now. Almost there. So this could just be because these values need to be right. But I think slopes won't matter here. Because we're just trying to work out which direction we should be drawing the line from. Which means, what do we actually need? Let's go through. Let's go through from the beginning. Okay, so dx1, dy1, dx2, dy2, they're used to calculate these lines here, which give us the px1, px2. So, aha. So the problem we have here is px1, px2 are d words. So we need to do this multiple times when we do the switch. Because what do we actually use? Let's see which numbers we actually use in here. Where's our px? Okay, no switch. All right, so this isn't switching enough. That's all it is. And then here we use 1 and 2, 1 and 2, 1. Okay, we use 1 and 2. We don't use px 1 and 2, y 1 and 2. Yep, all right. So we'll put the plus zeros in so it's obvious. I feel really bad for complaining about Andy's listens now. It's gone all quiet now. He knows I'm not serious anyway. He knows I'm joking when I say it. It's just kind of funny, that's all. And what makes it more funny is with the lag as well. So like I'll say something, and then 10 seconds later I'll get a listen. Oh, don't sulk. We love you, Andy. He's preparing the revenge. Okay, I've just done 0 and 1. It should be 1 and 2. So let me change that. Also, this is going to say duplicate labels, so I'm going to do 2 and 1. So 2, 2, 2, 2, 1, 1, 1, 1, 2, 2, 2, 2, 1, 1, 1, 1. All right, I think that should be right now. Yeah, BG. Yes, I've got to say, Andy's BG list is pretty genius. Oh, what is it? Wow. Okay. What is it doing? What the fuck? Right, should just be switching those values. So let's just check that. So let's put these in the right order. Not that it matters, but so it's just double check. There's nothing else that's using the lower values. Oh, what's this? Store destination address. Oh no, that's just the line destination. Okay. PX, yeah, PX1 plus 1, yeah. All right. This should not be anything different. It should just be PX1 and PY1. So which means we should be swapping them here. So this should be taking px1, storing it here, which then gets stored at px2. Then we take px2 and store it at px1. Okay, and then this copies the same thing. So this should always be 1, 2, 1, 2. 1, 2, 1, 2. Yeah. This should be storing it here, px2 to px2, and these should all be 2s. Okay, so all 1s, all 2s. All 2s, all 1s. Get the right way around. 1, 2, 1, 2. 1, 2, 1, 2. Yeah, 1, 2, 1, 2, 1, 2. Yeah, so they're all, that is doing the switch. Is that X wrong? Maybe that X is wrong. Maybe let me just check I'm not using X anywhere else because I know I have to load that in a couple of times. No, this is all accumulator stuff up here. And I think the very first thing it does before it goes into all this accumulator stuff is load the angle. All right. So it's not that. Okay, so what I'm going to do now is I'm going to make sure it is to do with the negative. I mean, I'm absolutely positive it is, but I'm just going to fix those areas first. I'm fairly pleased with tonight, though. I think I've managed to explain what I've done, and I think so far the code is going. I mean, it's slow going, but this is always the case with these kind of slightly experimental. That looks like it's skewing again, by the way. Anyway, I'll come to that in a second. So I'm going to load that color in the border there, and then if we hit this point, I'm going to load a different color in the border. I don't know what those colors are. Well, I know 2 is pink, judging by what we were seeing before. That was a missing one from that series. Okay, yeah, so pink in the border. And then when the border goes black, it's perfect. So it is just those negative values. Damn. Okay. At least we know where it's breaking. You can see why nobody got that one right. You guys get through the background so quickly now. I'm glad people have started submitting them though. That helps a lot. Okay, I'm in the wrong file. I feel like this is not working exactly right. I mean, this is definitely switching those values. PY1, PY2, and PX1 and PX2. They're definitely switching over. That's definitely happening with this. Problem is, it doesn't seem like that's actually having the right effect. So I'm starting to think that maybe these slope values are wrong here. Because at this point, wait, they don't match. They don't match that file. X positive, so X. All right, let's just try switching these around. It's probably going to be wrong, but I'm going to try it anyway. Okay, so the X and Y's have stayed in the same places. So the Y's are when these are ones, which is correct. But the positives and negatives have changed. So let's try that. All right. See who that was. Thank you for creator for a follow creator Minecraft server. Thanks for the follow. Appreciate it. Oh my god, I keep doing that. Loading the wrong one up. You type that one in. Yeah. Ah, but you see now it's right, but it's mirrored. Um, Crap, I need to think about this because this is correct, but now it's mirrored. Thank you very much for the sub as well, create a Minecraft server. Appreciated. Cheers. Making me drink vodka. Every time somebody does something that triggers an alert, I seem to feel the need to drink. I don't know why. It's not like I promised to do it or anything, it just happens. So anyway, cheers. So looking at that, the moment it gets into the negative thing, it goes into a mirror mode. Which means if I just draw that same line backwards, then it should be fine. However, oh, it has to be. It has to be. I have to draw the line backwards. Okay. Okay. That's relatively easy to do. That's a buffer thing. Okay. So given the angle that we're at, okay, so what I'm going to do is, first of all, I'm going to move the params out. And the reason I'm moving the params out is so that I can put them here as part of this. So this will be all kind of one thing that gets added together, but it means that these appear before that. Thank you, Anton, for the bits. Once again, you're far too generous, my man. Also, you will notice as well when the line goes back the other way, there's a inconsistency, and this is to do with the you'll notice on the left hand side of the screen that the line is not quite right. You see it when these, yeah, you see how it bends like that, and that's to do with that offset pixel, so that we noted last time. Um, Quick question: I'm taking introductions to programming or COP 1000 Python for my project. I have to interview someone who does game development. Would it be okay if you to interview you? I can pay you for your time. Thank you. I mean, you're donating subs, so yeah, sure. If you send me I don't know how you want to do it. If you send me a message, if you join my Discord, go into my Discord. Someone can post the link to it, and send me the questions on. Yeah, I'll do it there. Oh, Andy's done it as well. Yeah, just go into my Discord there, and then if you could send me a message sometime tomorrow, I'll try and find some time. I don't mind doing that. You don't have to pay me for it; it's absolutely fine. Unless I mean, I don't mind giving you a little bit of my time. But yeah, feel my relationship to vodka, me likey and one eye coding. But yeah, by all means, if you wanna ask me a few questions, that's absolutely fine. It's up to you how you want to do it. Just let me know. Send me a message on Discord and let me know. Just not tonight. It'll have to be tomorrow because I'm going to be far too drunk tonight to do anything. But I assume you are Goatman on Discord. Thank you very much for the subs, by the way. Gift subs to Riker77 and Mr. Chippy as well. Thank you very, very much. Oh, and to Spudgunnus Maximus as well. Cheers. Just so you know, my game development is almost entirely hobby development. While I have coded games as my career, it's not been kind of typical video games. It's kind of been other things as well. Oh wow, the gift subs are flying in tonight. Thank you very much, Creator Minecraft Server, for the gift subs. That's 8 you've come in. I barely know, and you've donated 8 gift subs already. Thank you very very much. I will drink all my drink now to say thank you. Congratulations to Gunstar Heroes, Junkyard Tuning, Moose Remuski, Bolt Thrower 736, and Kablooey 98. Can Shannon get partners here? I think I need like 100. You need 125 viewers or something crazy. So Oh, and more as well. You're being far too generous. Bad Scribbler and Radak Hanilka, congratulations on the gift sub from Creator Minecraft server. Mm. It does mean I get more drunk. That definitely happens. Let's just finish the bottle. Need more Fanta. One sec. Ooh. My dog watches every stream. Wait, you don't? You haven't bought your dog its own Mac? That's just mean. That's just mean. Why aren't you lining Apple's Tim Apple's pockets? That's his name, right? Tim Apple. Tim cooking apples. You need to line Tim cooking apples pockets with money. I joke, but I really wouldn't put it past Apple to come out with some device for your pet. Does it now work correctly? Yes. So it's working correctly. The only problem is now is when we get to the point where the line needs to be drawn from point 2 to point 1 and not point 1 to point 2. It's still being drawn by the buffer from left to right on the screen. The buffer should be drawn from right to left when it does that point. So what we need to do is, and this is why I've moved the parameters out. You can already put an Apple tile tracker. Oh my God, yeah. Yeah, I was distracted as well. Distracted by the generosity of you all. You're all absolutely crazy. Last couple of weeks have been slightly mental. You're all very good, far too good. It's good to me at all. But I mean, it's all good because you know, the more that goes into the stream, the more I can give you all. So without a doubt, next month I'm going to be giving away 2 of the Nexus boards. Oh, I don't know if Gare Stram is watching now, but or the new guy, whatever his handle is on chat now. But your Nexus board that you won last month is going to go to the post office on Monday. It's all boxed up. I've built it, tested it. It's all ready to go. I'll be shipping that out on Monday. I don't know if you're in the chat at all, but it will be getting shipped out on Monday, so you can expect that soon. We have got, by the way, about 2 weeks left. It'll be 2 weeks today that I do the game like show the games for the game challenge and do the draw for those. Good question actually. How is everyone getting on with that? Can we do a vote for that actually? Can we see how many people are actually partway through something at the moment with that and will have something to show, um, or intend to. And then next month, and I still know, Andy, I do need to run this by you actually. So tomorrow I'll probably send you a message just to let you know about what my next challenge is going to be. You don't have to try it; it's fine. It's probably quite a long challenge to quickly have a go at. But I will send you a message just to tell you what it is and see what your thoughts are on it, because I do need to write something for it. So yeah. Anyway, all right. Let's finish off. This is the Milfort challenge. Yeah. It'd just be good to get an idea of whether or not I'm on the right track. And next month there will be 2 giveaways. So we will be giving away 2 Nexus. Well, actually, be 3 giveaways. 2 Nexus 7s I'll be giving away, and then probably the week before I give that away, or the week after, I will give away a Pi 400. So you'll be able to win one of these. Oh my God! Create a Minecraft set. God, you're too generous, my man. I definitely owe you an interview. That's for sure. So please feel free to contact me tomorrow, and I will absolutely give you an interview and let you know what you need to know. As I say, just bear in mind my game development is mostly hobby stuff, but I have been doing it for quite a long time, and I can probably give you some insights on some stuff. So, and you know, I do I do run this channel where we teach people to game program. So yeah, it's just very retro. But yeah, absolutely. Thank you very much for the gift subs. Cheers. Um, gift subs to Monopoly, Goblin Prince, Edorphus, MK Misfit, Trades Platter, Jez Jutes, Nets, Petrif FJ, 76 Iceman, and LX Lax as well. Thank you very much. Very much appreciated. So, for those who haven't been on the channel before, what I'm talking about with the giveaways is every month I hold a little competition, a little coding competition. Sometimes it's just a kind of get involved competition. Sometimes it's sometimes it's about the coding competition. Sometimes it's what am I on about? Sometimes it's a prize draw. Sometimes it's a competition, and at the end of the month, I give away to the winner or whoever wins the actual prize draw. Um, a Nexus 7 device, which I don't actually have right at the side of me at the moment, but basically it's an FPGA board that allows you to run the Mega65 core. So um, wow, it's absolutely mental. Okay, so I'm assuming it's Goatman on Discord. So let me just write a little message here. So uh, I'll be happy. There we go. I'm automatically subbed as tier 3 at my own channel. Andy. Oh my god. Okay, thank you, Goatman. I can't really talk much now, but yeah, if you give me, yeah, just send me the interview questions and interview me on Monday. Yeah, it should be fine as long as I'm not busy at work. I do work during the day, but if you send me the interview questions and then I can answer them. I'll do my best to answer them as quickly as possible and get back to you. So yeah, no problem. And thank you very much for all the gift subs. Very much appreciated. All goes towards making the channel more fun for everybody by providing these giveaways. And for those who aren't interested in the Mega 65, as I say, next month I'll also be giving away a Pi 400 starter kit. So it'll be a Pi 400. You'll get, I think it comes with an SD card. I can't even remember what's in the starter kit. I think it comes with an SD card, power supply, a mouse, I think, is in it as well, and then a little book as well that teaches you some basic programming on it. So there'll be one of those next month for those who aren't too interested in the Mega 65, and that will just be a pure prize draw giveaway based on tickets. So you'll buy tickets with the channel points, so save some channel points for those. And then those channel points you'll be able to use to purchase tickets to enter the draw, and then whoever, you can purchase more than one. There'll be a limit on how many you can buy, but you can purchase more than one. And then we do a spin the wheel thing, or actually, it wouldn't be spin the wheel. It would be, what would it be? Spin the wheel. I don't know. I have to look into it. It would be something like along those lines, anyway. Um, oh no, it'll be my little giveaway draw thing. And whoever gets that, I'll send that to them. So it's worth about £100, I think, or give or take a few quid. All right, let's go ahead and change this buffer then. So what we need to do is we need to make the buffer draw the lines the other way around. So we need to flip it the other way around when the angle is at the right side. So that means basically the easiest way to do this is probably going to be to make sure we match these in here. So I'm actually going to read the slope type and just take that value. Now we could just say, well, if it's more than this and less than this, but it's so that we can make sure we maintain that kind of connection between these two. We're going to read the slope type from here, which means we definitely need to kind of put this into a single file so we can guarantee the order is correct whenever we do things. So in here, copy. So where's our destination to screen? Okay. Wait, hang on. If if we're drawing the line backwards, if the data's backwards, then it's this, isn't it? This is different. Hang on. I need to think about this because we have some data in the buffer, but the data in the buffer is a line that's drawn in the opposite direction to what we're used to. That now needs to be drawn backwards on the screen. However, the line always has to draw positive in the x direction. So we can't actually do that. But what we can do is we can read the data backwards. I think we can do that because we're using copy in here. So we're turning line drawer on for here. We're moving. Is that our step? That's our source. Oh yeah, that's right. So that's moving that way. Our source is a destination is a line. Okay, so the line is always going from left to right, but we need to read the data backwards. So this is the source address here. So whenever we fill this value in, we need to change it slightly. So this bit here. Okay. But at the same time, we need to switch some stuff around here. So the first thing I'm going to do is make sure that I'm updating this at the same time. And the reason I'm doing that here is so that I can guarantee that this is our base address for this line. So that's fine. But now what I need to do here is I need to load the slopes from the other one. So I need M7 tables. Oh, now that means this needs to be after to work, or else it's not going to pick up those tables. So I need to grab M7 tables dot slope type. And this needs to be, can I use X? No, because X is being used here. So I'm going to use Y. Okay, so I need to load Y with M7 params.angle. And then do this, and then and this with 1, 2, 3, 4, 5, 6, 7, 1. Is New Zealand and New Zealand, blah, blah, blah. Did that not work for some reason? Yeah, the gets removed. So if the is at the beginning of the thing, so if it's the something, then the is ignored. So if you type there, it just removes it, and the image won't have the in it. It will remove the from the beginning of it. So if there's in the middle, it does matter. So if it's like New the Zealand story, it also should remove spaces as well. So it didn't like who typed that in. Yeah, the image will have it. The image the name result will show with the at the beginning, possibly. And Magic Night, let's have a look. But you don't need the New Zealand story. Yeah, that should have worked. I need to put some more debugging in around that, so when things don't. Yeah, so New Zealand the story would matter, yeah. But it should ignore the space, so it should still work. But I need to put some debugging in, so when things go wrong, we can just press a button. So anyway, Okay, so if that value is non-zero, then we just jump. Sorry, if it's zero, then we just jump ahead. However, if it's not zero, then what we need to do is we need to change the source address, and we do that by taking the buffer vector from here and adding our length in. So our length, step equals length divided by right. Length is in. Where is our length? Oh, here. D770 and D771. Okay. So what we would need to do is this that we're doing here. So I'm going to do that here. I'm going to take source address and I'm going to add the length in here. Now that's going to give me the very last byte plus one. So I need to take one away from this. So when I've done this, I also need to subtract from one from this. Now, no, I can't because it's not in zero page. Okay, that's fine. So at this point, I just need to do. This is kind of slightly annoying. So it's a bit long-winded, but the cool thing with this is we are working with 40 megahertz. So even though it seems like a lot, it's not going to be that bad. Oh my god, who's at it now? Anton is at it now. Thank you very much, Anton, for the gift subs. We're not going to have many people left to sub, but anyway. You might want to think about scaling the draw rate, taking the average of each line and subtracting from the total width height, and then want to actual width height. Clean up the draw on screen so it's not so pixelated. Yes, but then you're going to lose resolution. So the reason it looks so pixelated at the moment is because there's no subpixel accuracy in the scanning across the screen. So that is causing a bit of a problem, but it's something we're going to address soon anyway. So thank you, Anton, for the gift subs to Encode Games, Velisip, Mr. Maru, Brandon PDX2DC, and Rej2. So I mean, it's scraping the bottom of the barrel now to find who to give, because I don't know some of the even how to say some of these new names. Sorry, I don't mean scrape. That sounds really horrible on the people who've got the gift subs there. I don't mean that. I mean, I'm seeing names that I don't recognize at all. So, but welcome anyway, if you're on the stream, and congratulations on your gift sub. And thank you, Anton. Yeah, there's plenty of things we can do to smooth things out, but the key thing now is just to get it working. Once it's working, we can look at the different ways that we can smooth this out and create a less kind of jittery image. The other thing to bear in mind as well is that the source texture is only 512 by 512, so the resulting image is going to be pixelated. There isn't an awful lot we can do about that. We can smooth things out and we can take averages between pixels, but then we get into the whole kind of, I mean, essentially we're doing post-process anti-aliasing, and that is going to take even more time. Not to say we can't do it, we definitely can do it. We've got a buffer that we're drawing from and to the screen. We can definitely do that by having a third buffer, but I wouldn't want to do that right now. So I'm trying to limit the raster time so that I can do other stuff. Hey Paul, welcome to the madhouse. It's crazy. I've gone up like 40 subs on this stream. It's insane. You're all slightly mental. But I appreciate every single one of them. Thank you very much. I have to start having sub goals soon, and my number's less embarrassing. It's really disheartening when you see streamers with sub goals and they've got like sub goals. Like, okay, so you want people to sub, I get it, but then you see like 20,000 and they're at like 19,000. You're thinking to yourself, God damn it, 20,000 subs, and they're still begging for subs is craziness. I don't think you'll ever see me beg for subs at all. I don't even think a sub goal is likely, to be honest. But yeah, quality over quantity. Yes, exactly. Although to be fair, some of the streams I watch that do have those are actually quite good streams. So That's fine. Okay, so now we are counting from the end of the line. Uh, and a gift sub to Paul as well. Thank you very much, Anton. Unless it's a Subway sandwich. Oh, I beg for a Subway sandwich. Actually, I'm not that keen on Subway anymore. I used to like it, but I think I ate too much of it once when I was working in Chiswick, and I just had far too much. Um, and it became a bit of a problem. Oh, you will probably notice here, Paul, as we reach, so as it goes around and the rotation appears to kind of mirror and go the wrong way, like now, you'll notice as the track goes on the left hand side, how there's like a weird curve distortion on that side. That's that line, that extra pixel of line drawing across. It's because it's scanned a line backwards, and the beginning of that line is kind of too long before it enters the slope. So you can see where it's kind of having an effect on the graphics, because that's then being scaled up, so that what was just a couple of pixels of slope incorrectness at the beginning is now blown up into a kind of much bigger slope incorrection. So um, yeah, it'd be good if we could address that at some point. I get that it's low priority, but it would definitely be handy to have that. I've had that done at some point. Okay, so I'm going to just take the buffer vector, which is the original values for this now, and do that. Okay, so this should, in theory, change the address to the end. Now we just need to make it go backwards. I can't remember how to make it go backwards now. Oh, it's God, I'm getting quite drunk as well. Yeah, there probably aren't that many people. I think we've had almost as many subs as there are people in the channel right now. It's kind of crazy. Yeah, awesome. If you need me to add, I can't remember if I added an issue for it, but if you need me to add anything, I've got an example program I can put in. I may have added an issue. I can't remember if I did or not. Oh my god. Oh my god. Create a Minecraft server. Thank you very, very much. You are absolutely insane. There are people I'm pretty sure aren't even in the server now that have visited the server at some point in the history. And okay, I think we're absolutely going to give away two next. Yeah, I mean, well, I was already going to give away two Nexuses on the next stream, and now I might end up giving away two Raspberry Pis as well, Pi 400s, because you guys are absolutely insane. Yeah, absolutely mental. Thank you very much, Creative Minecraft. So, as I say, speak to me tomorrow. I will answer whatever questions you've got on Monday, whenever's best for you. Uh, yeah, my sub count has almost doubled on this stream. That's kind of insane. I think I had 76 subs before the stream, and I'm up to 135 now. So uh, yeah, people are amazing, and that's why I'm perfectly. If this was any other kind of stream, if I was just doing let's play a game or anything, then I'd be keeping every penny, and I'd feel perfectly all right doing that. But this community is so nice and so generous, and and they all help each other so much. I absolutely want to just give back everything I can, and I love it. I think it's absolutely love it. So um, yeah, it's very very cool. It's very cool, and you guys are just proving that point tonight very much. Thank you for. I'm not even going to read the list out; it's too long now. But congratulations for everybody who's just received a sub from Create a Minecraft server. I recognize very few names on that list. Oh, Mr. Cola's on there. Proton Fig's on there as well. Satan's Nips is on there. I remember that from the other night. There's a few people. I think it's people who've been in the stream before, mostly. I don't recognize everybody there, but thank you very, very, very much. So it's appreciated. And as I say, I'm more than happy to answer any questions you have. Um, just give me a private message when you want to, and we'll I'll get back to you as quickly as possible with the results. Okay, so what I need to do is just change this value in the copy. So this is the source upper byte, and I need to add or it with this value basically. So that is in my DMA. That's going to be this value here. So source direction, and that's going to be that plus no, just that. Okay. Okay, so what I'm going to do is I'm going to start by taking that value. I'm going to AND it with the subs are going to go on forever. uh, thank you very much. Just so I'm serious about it. Thanks so much. Yeah, no problem. Good luck with your assignments. Take care. Thank you very, very much. It's very much appreciated, creator Minecraft. So, hope we see more of you in the stream. You seem like you're quite a lot of fun. So, good to have you around. Not because of the subs. I mean, obviously that's very nice, but I just mean, it's nice to have more people, like-minded people around. So, and Proton figures there. Hey, Proton, how you doing? Okay, so and now what we need to do instead is if we do this, we just need to turn on that light here. So hopefully this should work. It might not. I might have got things horribly wrong here, but I'm hoping this is going to count through the source buffer backwards while drawing to a line forwards. That's kind of my aim, but we shall see, right? Hopefully that's possible. If not, at least Paul's in the chat and I can ask why. Are there any US sellers of? Oh no! Something's gone horribly wrong. Shit. All right. Okay, so let's start by just turning this bit off and see if I've broken anything here. I think maybe I've broken something here. This is because what I'm doing is I'm supposed to be advancing the buffer point. I don't. Oh no, there you go. It's working there. So it's working. Then it gets there and goes backwards. Okay. So why does that sometimes screw up? Load the angle. Load the slope type. And if it's equal to 0, jump to here. That just means half of the time it shouldn't be doing anything. I'm ending with 1, 2, 3, 4, 1, 2, 3, 4. Right, okay. So if it's equal to 0, I should be jumping here, which means none of this should be getting run. So what I'm going to do is I'm going to change that to ink D020 so I can see if I'm running that. I'm going to find any D020s in here, so these ones, because we know where that's we know where that's happening now. Ah, damn it! So I don't need to do that. I just want to see if it is doing that at the right point. Yeah, see, look, it's not drawing that. That's weird. Why? I bet you there's a value I need to keep, and I bet it's the Y. I bet it's the Y. I bet we're using the Y for something. We're using the Z. We're using the accumulator. Uh, yeah, thanks, Proton. This is using DMA to rotate with perspective a big image. It's definitely complex, that's for sure. The maths is kind of insane in it. But it's getting there and it's doing it on the fly, which is nice, and it's doing it super quick, which is the really nice thing. Problem is, for some reason, this buffer will not copy backwards. So either this is failing all the time, No, this is just adding values to source address, right? So source address 0, source address +1, and then subtract that value. But this should not be failing all the time. This should be jumping to here some of the time. Node y params angle, yes. Slope type, comma y, slope type here, slope type, comma y. Yeah, so this should not be failing all the time. This should only be okay. That flashing's driving me mad, so I'm just gonna start without the flashing for a second. Hang on. This machine's DMA can do rotation. Not quite. So DMA copy actually pipelines a bit. So first 2 bytes are before. Sorry. So what the DMA is actually doing, that's allowing us to do these. Oh, maybe it's this. Maybe this has gone wrong. Let's get rid of that bit. Hang on. So what this DMA is doing is it's reading straight lines, but then what it can do is it can basically step through. So it can do. It's kind of hard to describe what it's doing, but there's basically two functions that are going on inside this, which are allowing me to do this. One is fractional DMA stepping, so that is not moving one byte at a time, but moving any kind of fractional value. So using fixed point float fixed point values, basically. So that allows me to advance like half a byte at a time. And the other thing that it's doing is another type of fractional DMA, which is a line drawing and a line fetching DMA. So what that allows us to do is define a screen layout and work out if I was to draw a line across this screen, where would the pixels be on that screen? So it works out that I have to go across 2x across, then one down y, 2x across, one down y. So it can do this kind of line, like gradient line drawing with arbitrary slopes, but it can also fetch things in that order as well. So you define a texture layout in memory, and then it can fetch pixels from that texture in a line on arbitrary slopes. And so that allows me to do to grab a line from a texture, store it in a buffer, and then grab that line from the buffer and scale it up on the screen or scale it down on the screen. And that allows me to do the 3D that you see going on. Problem is, I seem to have broken something. I'm not entirely sure what. It's just, I wonder if this buffer vector thing is wrong. It feels like I've done something because it shouldn't be doing that now. Let's just go back a little bit on this. What did I do? So if I just see cancelling that out should be enough. I don't know why that's not working. Did I do something wrong in here? No, I didn't change that. Oh, there we go. So the problem I've got at the moment is half of the time it draws. So the lines always have to move in the positive direction on the major axis. Thank you very much for the follow, by the way, Chuck002. I think I missed it in all the sub madness. So what it does is it will, whenever you're drawing or fetching stuff in a line, or the line always has to be moving positively in the major axis. So that means if you draw a line around a circle, the major axis half of the time is going to be x. In other words, the difference along the x-axis is bigger than the y, and the other half of the time it's going to be y is going to be the major axis. But then half of the time those x-axes are going to be moving in a negative direction, and half the time those x-axes are going to be moving in a positive direction. The problem is when they move in a negative direction, we have to flip the line around. So we have to draw from the end of the line to the beginning instead of from the beginning to the end. So this is what you see in the demo here. Once the line becomes negative, what happens is the thing moves the other way around. So you can see now it's moving in a different direction now. And the reason it's doing that is because what we're seeing is a mirrored version of the actual what we should be seeing on the screen. And you see once it flips, it mirrors back again. And that's because while we are fetching the line in the right direction, we're not drawing it back to the screen in the right direction. So what I need to do, and this is what this is supposed to be doing here, is working out which direction we need to draw the line and changing those values accordingly. So unfortunately, for some reason, the moment I include this, it seems to break horrendously. And I do not know why. So I'm trying to figure that out now. So this is the value that we need to change. This decides which direction the data is read. So what we're trying to do here is we've got a buffer, which is linear texture data. So it's each line that we draw across the screen. And what we're currently doing is we're reading the little header, which tells us how long the line is, and then we're reading all the bytes for that length. So we're changing the length in the DMA to say read the next 1,000 bytes in this thing, and draw them to the screen. So there's a linear fetch, and it's draw into the screen using the line draw. So it's grabbing 1,000 bytes in linear sequence, in positive linear sequence, and it's drawing them across the screen using the line draw algorithm from left to right. That line draw algorithm always has to go from left to right. We can't go the other way because the x-axis is the positive, is the major axis, and in order to go positively through it, which we have to go from left to right. That cannot change. So that means what we have to do is we have to take the data in the buffer and count backwards from that. So we still draw in the same direction, but we start at the very end of the data and move backwards through it, which is what we're trying to do here. But for some reason, it's not having it. So what I'm going to do, first of all, is I'm just going to try just doing this. So I'm just going to force everything to go backwards and see what happens. I suspect it's going to be a bit of a mess because I'm not actually setting the end point of the data properly. Yeah, okay. So we're seeing it move backwards and then bounce the other way, and we're seeing the junk down the left hand side because we're actually seeing the length headers for the line. So you can see the blue band right on the left hand side. That's the 0, and the colors are the least significant byte. So as the length changes, those values change and the colors flicker, but the upper byte's always 0. So it's kind of doing what I would expect it to do by going backwards. So we definitely can count backwards. So that's good because that verifies that we can actually do this, or else I would have been bugging Paul for a bit more changes on this. But it's fine. It's doing exactly what I'd expect it to do. So the question is now, how do we make it do that based on the slope? So that should be what this is doing here. So first of all, I'm going to put this in. So what this is doing, this is just turning off the up bytes. This is making sure we're always going forward. This should have no effect on the it should have no effect on the way it looks at all. It should just be exactly as it was before, which it is. So that's good. So that's not a problem. So then this comes into question: is this the problem here? We're grabbing the slope type, but we are doing some. We are adding these values from the multiplier. Well, these should be all right as well because these are set up here. By in these values, these shouldn't be any different. They should be absolutely fine to grab. Just because they've been pushed in there, I can read them out fine as well. So I would expect those to be all right. And then this is just subtracting a value from the source address. So this is just making sure that the last address is actually -1, because what I'm trying to do here is find the end. This is our length. And this is the start address of the line. So the line buffer segment, this is the start address of it. So what I'm doing here is I'm adding the length to find the next header, basically. This is going to be pointing to the next header and then subtracting 1 from it. But for some reason, it doesn't seem to be right. So let's just put that in because this is just the condition. So this shouldn't change anything, and just make sure it doesn't change anything. and straight away it breaks things. So, what is it that's breaking things here? Is it because we're using the Y? Is Y being used somewhere else? Well, let's take a look. We've got reset buffer vector, which is happening outside. Copy buffer DMA. That's being called from in here. There's no Y being set there. There's no Y being set in here. So let me just try this. Oh, I know what it is. It's this. It's the loop that's wrong. This is why I started putting the word loop in these. It's because I've got a really long branch that's pointing to this. That's why. Okay, cool. So I can put those back and hopefully this should fix it now. Yeah, if you start a little bit before I finish, I can bring everyone over to watch and judge you. And cool. There we go. We've got a full rotation now. One thing I noticed is we've got some errors on that side of the screen for some reason. I'm not entirely sure why that is. Because that line should be just counting backwards, but it looks like it's missing a little bit off the end for some weird reason. And that seems to grow as we go down the screen, but we've got a full rotation there. There does seem to be a little bit of a hitch as it moves around, though. Let's just keep an eye on it. Okay, I think that hitch is because of the way that it's drawing that final section. So what we're seeing is the lines kind of shift back again as well. So I think so you can see down the right hand side we've got that kind of like a wavy blue line down the left hand the right hand side. So there's some kind of error going on there. I'm not entirely sure what it is. I'll take a look at that in a minute. It could just be this, actually. It could just be that this subtraction's not working, because that would scale up as we move down the screen as well. So let's try again. Uh, Probably won't go for super long. Yeah, so well, it'll be quite late. I mean, I'm gonna code till about I think that's working now, isn't it? Yeah. So you can see the distortion as we move around, and there's definitely a problem on. Oh no, it's not quite right, because you'll see a line of pixels down one side, so there is something slightly not right. Not entirely sure what that is. There's definitely some errors going on, but what we have now is almost the right thing, so that's really good. But yeah, it will probably be in about 2 hours time, because I will do this for about another hour, and then I will play some Resident Evil for about an hour as well. Okay, so I can definitely see some glitches that are happening. So there's a few things. Let's talk about the things that are wrong here. So the very obvious one is there's an obvious transition between the lines being drawn backwards and forwards. When the lines are being drawn backwards, you can see a row of pixels down down the left hand side. Need to figure out why that's happening. It could just be due to slight inaccuracies in the length count for some reason. Yeah, no problem. If Paul, if you're on, I'll definitely raid you. It makes sense. Um, so that's one thing. And that seems to be causing some other minor glitches as well. So you'll see when that happens, there's a little transition. You can see a jump. So watch for that line appearing, and you'll notice that there's a slight jump in the rotation. It was hard to see there, but it was definitely there, and you'll see it again in a second. So round about now, there you go. The little glitch as it moves around. So there's definitely something going on there that we need to figure out. It's almost certainly to do with the direction of the line draw, and to do with this routine. It seems like setting this to subtract 1 is not quite enough, because we're still seeing the wrong colors on one side. So I'm not entirely sure what to do here. I believe this is correct. I believe the fix is something else. So I'm going to put that back, and we'll figure out what the fix is on the next. Well, I'll probably do that on the next. Yeah, like an offset by one. Yeah, so that's why I took this off. But see, when I take that subtract one off, what we see on that right hand side. So at the moment, you see on the left hand side, we're seeing that it's just not drawing far enough across the screen. But what we're seeing when I do the extra subtract one is we're seeing that it's actually starting too far in the data before it moves backwards. So I think this is more to do with the difference between going backwards towards zero and going forwards from zero. We're probably starting on an integer. What we need to do is start on a fractional value. I think that's probably what it is. Um, yes. The problem is, I think what's happening is, so when we go from left to right, we start at zero, and the zero goes all the way to the end of a line, which may be 128.8 pixels wide. But as when you go from the other end, you start at 128 and you go down towards zero, so you actually finish at minus, zero point 0.8 or whatever. So it's to do with that kind of slight difference between that. The same rounding errors are what cause the kind of jitter in things as well, so we need to sort that out. There's the line, the initial point on the line drawing incorrectly as well, so we need to look at that. That's something that we can't really do anything with on there. um Not clear carry. No, it's not carry. I don't think it's a carry issue. I know what it is. It's to do with because when we draw the line backwards, we're no longer starting on an integer, and we need to figure that out somehow. Now there are some possibly some settings I can change in the DMA to deal with that. Likewise for the line fetch, I can do the same thing there. But yeah, the blue stuff is because the line's not drawing far enough across the screen, um, which is why that's happening. It doesn't know what to draw there, so it just puts zeros in there. And which is why it gets wider at the bottom, because this is probably just like 1 pixel in the buffer. But when it ends up on the screen, it ends up being quite wide. So you're seeing the width of 1 pixel as it's scaled from the buffer. So, but yeah, we're getting there. So what I'm going to do, I'm actually going to keep the angle, and we're going to move through the map at the same time. And I'm going to make it just do it a little bit faster. So the other thing that you will notice here as well, is that when we reach the edges of the map, weird stuff happens. So you'll see kind of things appear that shouldn't be appearing. You'll see kind of weird drawing artifacts with bits of the track just suddenly appearing, and that's because at the edges of the map we're not actually doing anything special. So what I do on the JavaScript one is at the edges of them, when I get to the edge, you see there things pop in and stuff. When I get to the edge of the map, normally what I do is, on the JavaScript version, is because I'm drawing a line 1 pixel at a time, taking a pixel, drawing a pixel, taking a pixel, drawing a pixel. Thank you for the follow, Nostalgia Nerd. Oh, Nostalgia Nerd. Hey, welcome. Cheers. Oh, shit. I got your book up there somewhere. Still halfway through reading it. But yeah, welcome. I appreciate it. Um, uh, 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 do it 5 times faster and we can't see any glitches. Yeah, that's true. That is very true. But yeah, you can see it popping in. And the reason it's doing that is because on the JavaScript one, I read a pixel, draw a pixel, read a pixel, draw a pixel. I'm not doing that on here. I'm reading one line, uh, buffering it, and then drawing it to the screen. But what that also means is all I have is the end of the line, whichever end I start at, and the length of the line. That's it. So I can't actually check if I can check if the beginning of the line is outside of the map. I can definitely do that. But then if I was to if I was to change that, I would have to make sure that all the lines, all the pixels along that line that are outside of the map are now turned to transparent sky or whatever the map at the edge, color at the edge. So that's going to be a little bit of extra stuff. What I'm going to have to do is whenever I take a line, the first thing I'm going to have to do is make sure that it's completely within the map. If it's not within the map, then what I'm going to have to do is what I'm going to have to do is work out which segment is in the map, draw that, and then fill the rest of the buffer in with blank data, um, which is going to be a bit tricky. But I'm going to do that at a later date. I just wanted to get this kind of working as it is. And by the way, this still isn't running as fast as it could. If I do it here, this is the full 50 frames a second effect. So you get an idea of how quickly we can do it. And this is just moving one unit in the y direction and 1 degree angle each turn. But you can do, I mean, you can definitely see it's doing strange stuff as you go around. But if we're looking in towards the map, everything looks fine. It's only when we're looking at the edge of the map that things go really weird. But in the middle of the map, absolutely fine. There's a few glitches here and there, but it's looking pretty decent. But it is very fast as well. This is the thing. So let's take a look at the border time for all of this now. So let's put those back in and take a look and see how quick this is. Make the borders blue. Yeah, I mean, we can definitely get rid of it. But yeah, look, there you go. I mean, that's not bad at all. I mean, that's using probably less than half a frame, just less than half a frame to draw this. So the gray bit is actually fetching the texture data, and the pink bit is actually drawing the data from the texture buffer that it's built up to the screen. And yeah, like I say, the only glitches are when the ends of the lines are outside of the texture area. If I just stick us in the middle and don't move us, so if I just get rid of this and put us in the middle, the only glitch will be that transition from negatively drawn lines to positively drawn lines. So let me change this to the middle. So let me do this in hex. It's a bit easier for me to find the middle in hex. There we go. Angle doesn't matter, and we're just turning around on that angle. We're not doing any movement. Just Luna. You're determined to make me do Luna with this engine, aren't you? So yeah, see, now that we're in the middle of the map, everything that we're drawing is within the middle of the map. It is within the map boundaries. So when we look at it in the JavaScript demo, we're basically doing this now. I mean, our far planes are a bit different, actually. I think our far plane is a bit closer. But essentially, what we're doing here is we're just drawing stuff that's within the boundaries of the map. The only things that aren't are going to be in the very, very far few lines, and we don't draw the far few lines. So the far few lines are missed because we've got this where is it, row start here. So the first 16 lines of the map we don't actually draw, which is why we managed to keep it within the map. And you can see that it's pretty much spot on, except for that glitch when we go from when we transition between negative and positive. You see, as those yellow coins appear on the screen, they glitch a little bit. So like now, I didn't do it that time, but there is definitely some glitch going on. So when you see the blue stuff on that side, there's a glitch. So that's what we need to take a look at next. I think we need to try and smooth things out and try and simplify as much of this as we can. What I am going to do though is I'm going to do another little backup. I know I shouldn't be backing up with raw files, but it's going to work for me. So just delete that one. Just because I don't want to commit this until I've got this, until I'm very happy with this. So this might take a little while before it appears in the GitHub, but once it's there, it will be free to share. What I might do once I start making the Kart game is actually no, I will share it as well. I'm not too fussed about the threat of CSDB stealing this because I don't think they're as bothered about the Mega65 stuff right now. But I mean, this is looking good, and we can play around with things as well. So let's try changing some values, right? Let's change the far plane. See what happens if we. So changing the far plane should, in theory, make us appear a bit higher on the track. So let's change it to like 70 and see what happens. So now when I run this, we should be a bit higher. This is the technique we're going to use for jumping, but this may need some thought about how to do this. And you can see, as I say, as we approach the kind of the long distance view of things start messing up. So you can see the horizon looks really broken there, which is why having the far plane closer to us is much better. Let's try a far plane of 24. So we go nice and low down again. Let's try changing the field of view. So the field of view, obviously, smaller field of view will make everything zoomed in, but kind of stretched horizontally. So let's try that now. We should see this same view, but with kind of zoomed in, if you like. I see it's far too zoomed in. Everything's stretched so much. You can see the stretching because of the blue at the side as well. And let's try the other extreme. So 64 is a 90-degree field of view. So this is kind of what you're used to seeing in default first-person shooters, around about 80 to 90 degrees. And that's what you see with that. And then as we move that above that value, so this is 135 degrees field of view, we'll start seeing things stretch out. So things will start looking really long and stretchy, the opposite of when we had the thin field of view. And then we get that kind of slightly weird fisheye look to everything. So there's a lot of options we can play around with, and they do affect the speed of the render as well. I mean, for instance, having a really long field, um, a long distance far plane and a wide field of view should make the routine take a bit longer. You can see it does take a little bit. Actually, it's not too bad, but obviously it breaks like crazy, so we're not going to do that. I think the values I had were probably about right, so we'll stick with those. Oh, sorry, that's the row 40, wasn't it? Was it 40 or was it 50? I can't remember the bloody value now. So I think what I'm going to do now, very, very quickly, is try and add a little bit of joystick control into this, just so I can move around in it and kind of view things from different angles. And instead of having it rotate like this, I can actually move around in it and see what's going on instead. So in order to make this work, actually, or do we? Yeah, let's add some joystick control. I think that's probably the best thing to do here. Okay. So instead of updating the angle all the time, which we're doing at the moment, I'm just going to get rid of all of this. And I'm going to jump to control, which I'm going to put down here. And control is basically just going to do some joystick stuff. So we're going to take the joystick port and we'll shift bits off. So we were up, down, left, or right. So up, we don't want to do anything, so we'll ignore that one. So we'll shift that to the right, get rid of it. Down, we don't want to. Oh, actually, yeah, we do want up to do something. We want up to go forwards. So if the carry is clear, we jump to here. Otherwise, we'll put some routines inside here to do this. So, oh, actually, no, I'm not going to do it like this because I want to use multiple. I'm going to do it. I'm going to do it the old-fashioned way, I think. So I'm going to store that at a variable. I'm going to call it joy down here. You'll notice I use zero page a lot less now because of the speed of the Mega65. I tend not to use it very often. So and with 0, 1, if that's equal, actually I can just do that now, can't I? Not that it matters, but I'm going to do that anyway, just because I can. As I can do that, it's kind of. Just on the last HTML computer test for the analyzer, and no signal errors there, just say now works great on a variety of monitors. Oh, that's really cool. Is the platform still secret? Oh, I'm intrigued. What are you on about? What platform? I want to know some stuff. Yeah, and if you count that improvements, like on 1 megahertz, right? Yeah, one cycle means a lot, but at 40 megahertz, one cycle really doesn't matter that much at all. Um, I mean, it's still useful to use it now and again, and yeah, certainly you need to use it for indirect addressing modes. But yeah. Oh wait, is this what I think it is? Is this what I think it is? Is this the is this the remote access? Oh, this is Game Boy. Okay, cool. Very cool. Anyway, yeah, you can do. You can do that you can do that uh in the Mega 65. So what you can do is you can do this. You can say like there's another register called the base register, base page register, and you can take a value and you can transfer it to the base page register, and that moves the zero page up to page two instead. So yeah, you can already do that. I use it in my floppy loader, so I actually transfer the base page to the location of the floppy code that I've got, so that I can use some zero page stuff in there without encroaching on any user's zero page that they've got set up. Um, so it's a handy way of doing that. So okay, so if this is equal to zero, we're going to jump to not up. Otherwise, we're going to do up. So I'm just going to do this in blocks like this, and then we'll fill them in. Uh, okay, and then on these other bits, I'm gonna now. I realize that the accumulator may already be set to joy, but I may be doing other stuff in the middle of these, so I'm actually not going to store it. Not trust it to be there. I'm just going to grab the one that I've stored. So this is my usual way of doing these things. It's not the neatest way of doing things. I mean, you can do this with shifting as well, and I'm sure if you spend a bit of time, you can make it work quite well. But I'm used to doing it like this. I don't mind doing it like this. It's absolutely fine. Thank you very much for the follow. I'm saying it slowly so I can find the name. Rusty Coat Old. Thank you very much for the follow. Appreciated. And with that, I need some more vodka. So I'll tell you what, I'm going to finish this little bit, and then I'm going to go and grab a bottle of vodka uh, and a cold drink. I've got some. Well, I'll put some ice in my glass. It's probably the easiest way. So I will take a 5 minute break in a second. Well, 3 or 4 minutes more likely. Um, left, right. There we go. Yeah. Okay. So I'm going to take a couple of minutes break. When I come back, we'll finish the control stuff off. We've got about 40 minutes left. We'll do 40 minutes of this, and then we'll fire up. We'll fire up the Resident Evil and play a bit of that. HDMI working perfectly in Mr. Two. Oh, okay. Oh, awesome. That is going to be a lot of fun once that works. I mean, that essentially gives you a really, really good alternative to a Mist. In fact, almost like an upgraded version. So, anyway, I shall be back in 2 or 3 minutes, guys. 3 or 4 minutes or something like that. I don't know. All right, right back. I pressed the wrong button. So you can have another race because I pressed the wrong button. So there you go. Uh, who's that character in the top right corner of the screen? That's me, Shallan. No, I know you mean. You mean who is that? Is that M Bison? I think it's M Bison, isn't it? Uh, Fortunately, it wasn't the toilet cam button. Yeah, yeah. This is why I need a better overlay, admin panel, so I can do these things properly. Let's put it back on that one. Okay, so I got a nice fresh bottle of absolute raspberry out of the freezer, ice cold. Absolutely the best place to keep vodka, the freezer. Just be careful when you pick the bottle up because you will just drop them. So some nice ice in my glass as well. Holy shit, that is cold. Oh, the race! I remember that. That was an amazing game on the Spectrum. I could have got that one. Damn, it's a really good game as well. Anything over yeah, I definitely agree. But the only one I do keep in the freezer is vodka. Although if I've got Jägermeister, that'll go in the freezer as well. I'm not a big fan of gin. I think because for me, gin is always gin and tonic, and I cannot stand tonic. I think it's horrible. Um, and so it can whenever someone mentions gin, I think of gin and tonic, and I know I shouldn't, because I've had gin and like lemonade, and it's fine. But unfortunately, I always think of bloody gin and tonic. Tonic water is disgusting. I don't understand. I really don't understand that at all. Such a horrible flavor, but people seem to go crazy for it. And there's whole like gin bars. I remember there's a place we sometimes go to. We've got some friends that like to go to this bar, and it's just a gin bar. So you end up. I mean, thankfully they will do gin with something else, but everything is just gin. Um, Tonic water is either very bitter or not. Yeah, it's bitter. It really doesn't sit with me at all. Something about it just makes me shudder. It's horrible. It's just a very unpleasant flavor. I don't know why. It's very bitter. Yeah, it's the quinine in it, quinine or whatever it's called that's in it. I cannot stand it. It's horrible, horrible. Uh, Badly cooked cat. Yes, yes, that's not a bad explanation of it as well. Well, it's like the fake truffle oil as well. So fake truffle oil is some chemically thing that they manufacture to taste like truffle oil. Unfortunately, for some people, it tastes like petrol. So like my girlfriend cannot stand the truffle oil. So when she has anything like truffle oil cooked chips or something drizzled with truffle oil, unless it's actual truffle oil, which is rare as hell to get on a meal unless you're spending a lot of money, it tastes like petrol to her, so she doesn't like it. Whereas I love it. I think it's beautiful. I think you're in the petrol category, yeah. Yeah. Coriander tastes like kerosene. Really? Coriander's beautiful. It's weird, isn't it? It is really weird like that. Bean starch in food is gross. Ah, that would explain. So I know some people who cannot stand baked beans, and there's two reasons why they don't like it. Some people don't like it because of the texture of baked beans, and some people don't like it because they say they taste weird. So maybe that's what it is as well. Coriander tastes. Yeah, my girlfriend says coriander tastes like soap to her as well. Uh, I can't understand because I think coriander is a beautiful flavor. Um, anyway, let's let's crack on. Interesting though, interesting topic, definitely. Okay, so let's do. So if we pull right, we need to increase the angle. So M7 params the angle increase. And because the angle goes from 0 to 255, we don't need to do anything else other than increment or decrement. It will wrap around automatically for us, so that's good. Now, this is where things do get a little bit tricky. If we push forward, we need to move forward. So you would think, okay, we need to increase our position, but our position is in 2 dimensions, X and Y, and we need to move that according to the angle. So we might already have this table in here, but I have a funny feeling we don't. No, we have this table, which is close, but it's not quite what I want. And also what we're doing here is we have X and Y, but we don't have fractional values, which we should have. So I'm going to put X frac in here. And the reason I'm putting it before this is because if you look at this in little endian format, this becomes the fraction, then it's the least significant byte, then the most significant byte. So it's going to allow me to do some proper stuff with the fractional stuff, and it won't break any of the other logic that is based on the X and Y. So I can just increment these 3 bytes as you would expect a 24-bit value to be incremented. But what I need to do is I need to create a table for that. So I'm going to create another table in here. We'll go through and change these tables next time, or I may do it before the next stream. So there will be another one on Tuesday, I think. Actually, maybe not. I need to see what happens on Tuesday. I might have a really busy day, so I don't know what will happen then. Also, I'm fully expecting my PlayStation 5 to come next week. So if that does come, there will be at least one stream where I play Ratchet and Clank as well. So okay, so let's do X move, let's call it, and Y move. Okay, so X move is these are really simple, right? These are just going to match these values, right? So X move is I need to fill this with 256. It needs to be 1 for each angle. It's going to be sine our value of 256. So this is going to give us a value from 0 to 1. This here, which we then times by pi times 2, which is going to give us all the values of X for every angle. And then we need to times that by which I'm going to call M7 move factor, which is going to be our maximum move factor. Now this needs to be 0 to 128. Anything more than 128 and it's going to be a problem because it needs to be negative as well. So for now, I'm just going to set it to actually 127 is going to be the maximum. 127 max. There we go. But you'll see what I'm going to do with that in a minute. I'm going to actually double it or triple it or something to double it or quadruple it to get a movement value. And then this is just going to be the same, but with cosine and times negative move factor. So the reason we need to do negative move factor is because normally when you do cosine and sine, y is upwards in the when you draw the axis Cartesian kind of axis, y is up on the graph, but y in the case of screen coordinates is down. So even though the angle for a circle is sine x equals sine angle, y equals cos angle, because our circle is kind of flipped upside down, we need to flip the y as well. So oh nice, good guess. This is the probably the hardest series. I think I can't imagine you getting all of these by guessing them. I think these are going to have to be uncovered through the submission thing. I'd be very surprised if you managed to uncover them all without doing that. Anyway, the easy ones are gone. Yeah, yeah, exactly. There's at least 2 or 3 in this that I have never heard of. So, yeah. Anyway, I'll leave you to it. Cheers anyway to everyone. It's been another mental night tonight. I think over the course of this week, Tuesday and today alone, we've paid for the things. It always seem to you to want to see so UTC 100 should be bottom left of screen. from a maths point of view, yes, I would think that, but it didn't take me long to kind of feel normal. Because if you think about it, right, if you think about text in a book, right, line 0 in a book is the or line 1 in a book is the first row of text at the top, right? We just treat screens like we do print text. That's all it is. So it makes sense that your coordinates start from the origin, and the origin of a page of text is the top left, right? So that, I mean, that's why it's that way round. But yeah, I mean, it would have been nice. uh Deadly Australian things, or don't tell people what the series is, or else they'll know. But if you do want to add some images, by all means send me a zip file of images. Please make them all JPEGs, JPG, not JPEG, and make them all lowercase with no spaces. I mean, I fix them up anyway, and just let me know what the series is, and I'll add them in with your name and theme, and then you can put them in. What size? Uh, I don't know. Steps, what size are these? Steps knows. It's more about the aspect ratio than it is the size. So yeah, there you go. Yeah, give me the series title. Just name the JPEG, the thing that will search. So for instance, this JPEG is just Ford Fiesta.jpg with no space in there. Yeah, 4.3 is roughly about right. But if you want it to be exactly right, 1400 by 960 will fit perfectly in that box. Um, but yes, if you name the JPEG exactly what you want people to search for, then that's what they will that's what will trigger the image to show. So there you go. Uh, oh, I missed the poll. Yeah, 4 mil fort games from poll. Okay, but there's always a little bit more than there is on that. So, but that's pretty good odds. That means if you enter if you were in the vote and only the people in the vote end up entering the competition, then that means you have got a 1 in 4 chance, right, of winning the thing. So, but I think there's probably a few more than that. I'm pretty sure Aussie Phantom is doing one as well. I'm sure there's going to be other people who don't make the stream who enter. So I would expect a few more than that. But that's not bad. I kind of expect the game wants to be a bit less anyway. But yeah. All right. Okay. So Y move. Yeah. Okay. So this is good. So we've got our X move, we've got our Y move, and this value goes from 0 to 127. So what I'm going to do first of all is I'm just going to apply it as it is, and then we'll adjust it because it's going to be quite a slow movement. So let's just do up first. So what do we need to do? Okay, so I need to grab the angle. So I'm going to grab M7 params dot angle, and then I'm going to load M7 tables dot X move, comma X, and then I'm going to clear the carry bit, and I'm going to add that to whatever our value is up here, M7 params dot xfrac. Yes. Okay. Just that, and then store that here, and then I also need to oops. Like so, and then this needs to be done again, and it needs to be stored here as well. Oops. Okay, so that's doing the X, and then I just need to do the same on the Y. So I've already got the index into that, so I'm just going to do this, and I'm going to change this to Y move, Y fret, Y. Okay, so this is just pushing up, and rotation should work at the moment. And then all we need to do for pushing down is we just need to add 80 to this angle. So basically, this is the same as doing a 180, which basically gives the angle in the opposite direction. Or we could do the same thing, but with subtract. But I think it's probably easier. I see, it doesn't really matter, does it? It's probably quicker actually to do the subtract. So yeah, we'll do the subtract. So two ways of doing it there. I do like how steps comes in now and again and screws everybody's plans up. That's funny. I need to put an RTS at the end here. It's like everyone's about to get some steps. Just goes BG bender. Job done. Oh, we're still moving. Why are we moving? Control. Yeah, why are we moving? That's a very good point. So jump to not up, which would come to here. Oh, because these are the wrong way around. That's why. Because this should be branch if not equal. Damn it. So joysticks are pulled low when they're when the things are used, and they're pulled high when they're not. So also that did not seem to wrap round. So I think we need to make sure that this value and this value. Yeah, so I can turn like this. I can definitely move, but you can see it's very, very slow and jittery as well, which is interesting. But it is moving. The jitter is something we're going to fix. So, oh, and look, there you go. That angle's wrong as well. So actually, I think the Y might be not negative here. Something's not right. Okay. But the other thing we need to do here is we just need to make sure before we store this value here, we just end it with 0 on it. And that's because our texture is only that size. So we need to make sure that that wraps around and doesn't cause any issues. Interestingly, it is actually wrapping the edge of the texture there, which is good. But it's probably just because of the direction we're looking in. If I go up to this other edge over here, in fact, all my angles are completely wrong. All right, let's get rid of the minus there, see what happens. This is playing with plus and minus on trigonometry drives me insane. Yes, that's not right either, is it? So that's going like the completely wrong direction now. I push forward, I go sideways. I turn this way, push forward, I go forward. I push this way, I go forward. What the hell's happening there? Oh, I'm going backwards. Okay. Yeah, these are all wrong. All right. Because these could be negative. These could be negatives. So these values here need to match the negative values of these. Okay. So, oh God, this is annoying. All right. Okay, so what I'm going to do, I'm going to store y with 0 here. Actually, no, I'm going to try to think of the best way of doing this. If we're doing, oh shit, all right. Okay, so if this number is negative, then basically these need to be FF. If it's positive, these need to be 0. So what I'm going to do is I'm going to change this to SGN. I'm just going to call it sine like that. And do that there. And I'm going to do that here as well. And I'm going to create a little variable down here. I've got one called joy. I'm going to write one called sine. And set that to 0. And then at the beginning of here, I'm actually going to set that value to 0. So I'm going to take y 0 and store that in sine. But then what I'm going to do is I'm going to check here. So I'm going to put that before I load that value. And then I'm going to check here. So I'm going to put if that value, so if this is negative, then I need to do something. So if it's positive, I don't need to do anything. I jump to here. Otherwise, I'm going to set y to, actually, I'm just going to do that to save a byte. There we go. Store y sine. So I need to do that on here as well. So okay, and that's just going to make sure that when we add the values, that those values go backwards or forwards correctly and not Right, add weird numbers in. So they're never going to get it, Andy. It's hilarious. Okay, I feel like I'm moving. Oh no, I am moving forward. Oh, that looks really weird. Why does that look weird? Is it because I'm moving? It's because I'm moving fractionally, isn't it? That's why. Yeah, it is. Okay, so that's. Oh my god, this is going to get super confusing. Okay, okay. What I'm going to do then is I'm going to keep that, but I'm going to keep that as well. But here I'm going to add. I mean, this is really just temporary. Let's move high, and this will be add Y move high, and then this becomes the lower by. This becomes the up by, and that means I can change move factor to be something bigger now. But this is good because it lets me see the kind of jerkiness of the pixels in various directions. But look at that, I can actually move around a track now, even if it is kind of jittery. I mean, look at that, look at that road at the side. And you can actually see where you can see on the left hand side of the road there where the initial kind of integer locking problem is occurring. It's kind of a little bit annoying, but it's like thousands of car models. Boy racing cars back in the day. Uh, French car names. Oh, what? that was weird. Bloody French was bloody French was considered a weird term. That's kind of funny. I really hope on the next challenge you guys really get into it and give it a go. I think it's probably going to be more involved than previous ones, but I'm hoping it's still fun. So, okay, so I'm changing the move factor so we're moving a little bit quicker. It's actually going to move 4 times quicker than before. Just need to make that as Y move high. I don't think I changed it to Y move high. Oh, I did change it to Y move high. Okay. So it should be about 4 times quicker than previous, which should get rid of some of the kind of jitteriness from it, hopefully. Oh God, no! That's doing all sorts of weird things. What is that doing? Actually, that's doing super strange stuff. Oh, because it now needs to check this value here. Oh God! All right, so I'm going to change that to Y move high here. Actually, let me just copy that. Change that to high, and this needs to be here. It needs to be X move high. Honestly, I don't know how my my brain remembers to do some of these things. There we go. When I've had a drink, it's very bizarre. Oh, see, look, there I'm at the edge of a map, and it's doing strange things because it doesn't know how to render the edge of the map. So that weird corner there causes all sorts of weird glitches because it doesn't quite know what to do. You see there where the edge of the map is. and it tries to overdraw because it's confused about what it's supposed to put there. Uh, I think the field of view is kind of wrong at the moment, but because the track looks quite short, I'm not seeing very far ahead. And again, yeah, look where that's at the edges, it causes issues. So I definitely need to work on that. That's one thing. I'll do it at a later date. I'm more bothered about getting the smoothness of it right at the moment. I mean, the actual the actual speed of the update is nice and smooth, um, but there is definitely some line jitter going on. So you can see here on the left hand and right hand side. Look how bad that line jitter is. So this is when the corruption on the right hand side of the screen. Look at how those coins look. They look really bad. If I turn this way, it becomes less problematic because now the line jitter is on the right hand side of the screen is gone. But if I turn around so I can see those coins, they're still not right. You can see there's definitely the edges of the road are kind of sloping the wrong way, and that's because of this integer problem. So what I probably need to do actually is probably do some rounding on this. So if a pixel is at 1.1 position, then it's 1. If it's at 1.8, then it's at 2. That will solve some of it. But ideally, I need to have a think about how the algorithm is actually picking the starting points and how it's kind of picking the initial slopes as well. Because I think that's the other thing. I think the initial slopes will fix a lot here. In fact, it can probably. Let me think about this. If I'm over about 10 minutes, all right. It's looking amazing already. Yeah, it's incredibly smooth in terms of frame rate. I mean, this is running at 60 frames a second, 50 frames a second, sorry. Uh, and it's really not struggling at all. There's no part of this though which is causing the frame rate to really rise in any major sense. The problem is the accuracy at the moment, because some of the directions that you face, some of the I mean, look at that. You can't see the question marks on the blocks. Some of this can be addressed by upping the texture resolution by moving the texture up into Batikgram, which is what I'm going to do. Um, it's toast. Do toast. Oh, it's so funny watching you all guess. Yeah, and then you say no toast. I love that. Um, yeah. So anyway, I mean, this was the aim for tonight. The aim for tonight was to get this kind of working with rotation and stuff. I'm actually going to just play around with the field of view because now I can see things a little bit better. I noticed that it's quite short. I'm not really seeing very far into the distance. So I'm going to have a play around with the field of view and stuff. So first of all, I'm going to do it in here because it's quick to test. I have to make some kind of adjustments based on the changes I've made. So one of the things I've done is I've changed this plain multiplier thing to something simplified. But I can kind of emulate the values that I have. So the value I have is 112 here. So I need a multiplier which, when times by a value like 5, field of view is at 24. That gives me 120, which is probably closer to what I have at the moment. That kind of looks about what I've got actually. The problem is I am seeing more of the road ahead than it's actually showing on the screen. But that's because I'm showing 8. If I change that to 23, no, that's still. Hang on, turn that way. I feel like this number here is. Oh, I see. That's not changing anything. Oh, because I'm changing field of view. That's why. God damn it! All right, wrong one. Put that back to 40. Let's change this one down to like. Yeah, see, this is what's happening. It's clipping around about here. Um, yeah, that looks about right. So if I change the far plane, well, changing the far plane isn't going to change the maximum view height. So I need to make sure that this is always about 16 less than this, which it is at the moment. But if I change the field of view, that doesn't change anything. That just changes kind of, yeah, it just changes that. So that's at 0, but I can't set it to 0, so it's going to have to be there. All right, let's say I change this to 24, but then I have to set this then to so it's 120, 136. Okay, that lets me see a little bit more. So what if I set it to 30? It should be 150, so this would be 166. Ah, now that looks 150. Yeah, that looks a little bit better. So let's try that, a far view of 30. What was my field of view there? Because my field of view looked quite nice there, actually. 37. All right, so let's set a field of view of 37 and a far view of, I forgot what it was now. Was it 30? Yeah, far view of 30. All right. See how that looks. I think there is a no muffins as well. So let's get back round to that finish line again. So there is definitely some weird glitching going on. You can see that there's, but this could be down to the field of view. I did notice some field of views had some weird artifacts, so I'm going to put it back to 40 again. I don't know why that is. It might be down to rounding errors in the sine and cosine stuff that's means it's not fully accurate. There is some very weird stuff goes on with oh god, edge of the map again. Edge of the map stuff really is frustrating. It's definitely looking better though in terms of the finishing line. Here it is. So I was here before looking this way. It's going to be a case of playing around with the numbers and finding the value that works and gives the best view of the track ahead without giving too much. Oh, I love it. I love all the red dwarf stuff. Really, I really do enjoy that. All right, I think I'm going to call it a night there for the code. We'll switch over to Resident Evil for an hour. See if I can finish this before I doubt I'm going to finish it anytime soon. It's fucking massive, this game. But this is looking really promising. I shall stick a video tomorrow on the on Twitter and on the channel just to show this because I think it's looking really good. It's definitely worth showing off a little bit, and then we'll on the next stream we'll try and solve all the glitches. That's going to be the next big thing to tackle, and there's a lot of them, so it's going to be fun. But you know, we're there. We're proving that we can do it, which is good, and we can do it in probably about a quarter of the available raster time for a screen. So that's pretty decent, I think. Okay, so let me switch over. I don't think there's races or anything going on. No, go on. Have one last guess of the backgrounds. See if we can figure out what it is. I'll change my stream details in the meantime. Let's change it to Resident Evil 1 PSX. I think Andy, you've created the best series yet because nobody's gonna get it, and they're gonna kill you when they find out what the connection is. What do you call it? Oh God. Shimmerbot. Shimmerbot is the worst. Shimmerbot is the worst. Ah, God. That's a tip. I honestly, I think even when you know what it is, you're still not going to get it. Even when you know the connection, you're still not going to get it. Tell me a fact about cats. In Japan, cats are thought to have the power to turn into super spirits when they die. This may be because, according to Buddhist religion, the body of the cat is a temporary resting place of very spiritual people. Oh, okay. Bit worried. Cards made in Doncaster. No cards are made in Doncaster. They may be burnt out in Doncaster, but they're not made in Doncaster. All right, let's switch over then. Where's my pad? All right. Overlay's going to go off and everything now, so don't worry about the sudden jarring of the music disappearing. Let's just open this up. All right. Okay, so I've got to get to the right one. I think it's this one. I do this every time. I can't remember. Cars stolen in Doncaster. Yeah, number exceeds maximum integer. I don't know when there's an Echo Shares it. Asked for cat facts. How to say cats can get type of AIDS. I was like, what? Yeah, they can. They can get type of AIDS. There we go. Yeah, no, I forget what it's called. I think it's just called feline HIV or something. Oh, sorry, I can't remember the exact name for term for it, but yeah. All right, let's load this up. So I'm just going to spend about an hour on this. I don't want to spend too long on it, but hopefully we can get a little bit further. FIV, that's it. Yeah, I knew it was something like that. So I need to turn the music up now. Bear with me with the levels of the music. I realise that might be too loud. Take care, Warlock. Thanks for joining.